Good morning, ladies and gentlemen. Welcome to our second day of Hong Kong Open Source Conference. On this day, there are two tracks at 10:20. The first one is HEDI, Multilingual Programming for Education by Jesus Pillay in MWT1, which means that in this room. And refining data structure and algorithm implementation in the Linux kernel for improved performance by Kunwei Chiu in MWT2. If you want to know more about algorithm, just feel free to go to MWT2. At 11 o'clock, we have AWS workshop in MWT6 on the first floor. If you are interested in AWS, just feel free and just remember to join this workshop. Before the end of this event, we also have JetBrains license lucky draw after lightning talk. Also, if you want to join the lightning talk, just feel free to register outside this room, which means that the reception part. Let us begin the events today at 10:30 and start our first session. Good morning. Coming up next, we have Jesus Pillay to share about HEDI, multilingual programming for education. Let's give him a big hand.
Hello everybody, my name is Jesus Pelay. I am a developer in the HEDI programming language, and I also teach computer science in the University of Carabobo, located in Venezuela, where I come from. And today I want to talk to you a little bit about the HEDI programming language, what it is, the ways in which it might be useful to you, and different ways in which you can also get involved in the project. So let's begin. And first, I will summarize what HEDI is real quick in 3 core tenets. So HEDI can be said that is a gradual multilingual programming language built for teaching. And I know it's a bit of a mouthful, but I will be explaining what each of these concepts mean in the context of HEDI. But before doing that, let's delve a bit deeper into the misconceptions that we as programmers have when teaching programming. Because we know programming, that's easy, right? Teaching programming is not that hard, except it isn't. And we have a series of misconceptions and wrongdoings when we want to teach programming. And the first one is that we think that compilers are friends, right? They give you the error, the exact place where it's located, so you can fix it. But compilers are not your friend. They're merely a tool. And they are very much designed for professionals. A compiler is designed for someone who works professionally doing programming, and not for a kid who is just starting to learn programming. Perhaps they are not as proficient with computers or even with reading. So error messages and compilers are really intimidating to them. And the second issue is also comes from the fact that compilers and programming languages are designed for professionals. And we often think that syntax is not really an issue, that you can really begin programming and you can overcome the syntax barrier quite easily, because that's not important. The important thing is to begin programming and learn the concepts. Except that syntax really poses a barrier for students. There is a study that says that 50% of programs submitted by students have errors, and 75% of programs submitted by the weaker students have errors. So these are not students that are having fun with a compiler. They are throwing everything they can at the problem and see what sticks. So we think that we can improve the learning experience of programming by making syntax simpler. And this third misconception is that we mostly learn alone. We think about learning programming as someone sitting in front of a computer, reading a book alone in the room, but that is not true anymore. Many schools in the world offer programming as in their curricula. So we must design tools that are tailored towards that demographic, people learning programming inside of a classroom. And these were some of the misconceptions that were in the mind of Felina Hermans. She is the creator of HEDI. She is a PhD researcher from the Netherlands, and she was teaching programming as a high school activity, as a Saturday activity for kids. They asked her if she could teach them programming, and she said, yeah, of course. And the language she chose to teach programming to the kids was Scratch. And Scratch is a great language. It's simple. There are no error messages. There is no syntax because you program by rearranging the blocks, and it's really fun because you can, for example, this program here makes the cat do meow meow sounds and move around. That's really fun. But as time went on, the kids said to Felina, well, this is fun, but we want a real language. This is a toy. I want a language that is used in the real world. So she chose Python. And Python is another great language. It's used in many schools to teach programming. Many professionals use it as an engineering tool. So that's where the problem lies. Because Python is still designed for professionals. And for example, if I want to teach this snippet to my class. This is the first class of programming. I want to teach them to print something, which is not that exciting. They come from scratch where they were making the cat move around. So now they have to print text on a screen. But this is the first class. They have to go along, right? So if I want to teach them this, I have to tell them you have to write print on the keyboard. Then you have to write opening parentheses, which is Shift 8 in the keyboard, then the quotation mark, then the text, another quotation mark, and then a closing parenthesis, Shift 9 in the keyboard. Because they don't really know to type in the keyboard just yet. Kids, they are not as proficient with computers. So if everything goes well, we have text on the screen. How exciting. But what happens when there are errors? What happens, for example, this kid here? He wrote print using an uppercase P. And if he clicks run, boom, we have this error message. There is traceback, there's a file path, there is the code, and then at last, you see name error, name print is not defined, did you mean print? And as error messages go, this is not really the worst. There is even a suggestion there at the end. But before reaching that suggestion, you have to screen through a bunch of stuff that you don't really care. And if you are a 12-year-old, what are you going to do? Teacher, please help me. I don't understand this. And as this kid is asking for your help, this kid also made this mistake. So this kid here wrote what they think was a perfect program. But we know that there is an error there because there is a red squiggly line. So what happens if they click run? Indentation error, unexpected indent. Teacher, what the heck is an indent? So as you can see, Felina was not happy, the kids were not happy, so what was really happening? So we see here that if I'm trying to teach programming, if I'm trying to teach a snippet to someone, I don't want them to see the syntax. I want to teach the underlying concept. For example, here, I'm trying to teach them to their concept of repetition and that it will print 0, 1, 2, and 3. But what are the kids really seeing? They're seeing that there is space, there are brackets, there are columns, there are a series of keywords that they have to put in a certain way, otherwise it will fail. So we have short-term memory. Humans have a short-term memory that is really small, about 6 places. People that know programming, we can use our long-term memory to aid us. So for us, this doesn't occupy 6 places in our short-term memory. It occupies only 1 place because we know, oh, this is a for loop right away. But for a kid, it occupies a lot more because they have to occupy that with the syntax, with the column, with the brackets, with the spaces. And their mind is so occupied by the syntax that they are not really seeing the underlying concept. They have to first learn the syntax, and then they say, oh, this is what it does. So how can we solve this? How can we solve that this syntax thing is so complicated at first? How do other disciplines manage this? Well, we can look at language. If I'm teaching English to a kid, and at first I don't tell them, oh, that is an ugly A. That's very ugly. No, I tell them, oh, kid, perfect, you wrote an A. And then I teach them about words, and then about uppercase letters, and then punctuation marks, and then, at last, syntax and grammar. So what happened here? The rules changed gradually. We went from a really simple concept about just writing letters, and we ended up doing something really complex, like grammar and syntax. Imagine if I'm trying to teach a 5-year-old to write a really complex sentence. You can do it because they don't even know what a letter is. So that's kind of what's happening with programming. What about mathematics? In mathematics, something like this also happens. For example, if I'm teaching subtraction to a kid, first, they don't know about negative numbers, right? So I said that 5 minus 3 equals to 2. And 3 minus 5, you can do it, is 0 or maybe it's an error. But then, that's not true, right? I tell them, well, you can subtract 3 minus 5 equals minus 2. and the rule changed. And the same thing happens with a square root. First, I tell my students the square root of 4 equals plus minus 2. And the square root of minus 4, no. You can't do it. That's an error in the calculator. Except that's not true. And then I change the rule when I'm teaching them about complex numbers. And I tell them the square root of minus 4 equals plus minus 2i. So what would happen if we teach code gradually as well? And this is how Hedy was born. So it is a little example about one concept. This is a concept of printing text and getting input from the user. At first, in level 1, the code is really simple. This is a really simple programming language. It consists of only a handful of keywords, with keywords or commands, and there are no variables, there are no syntactic elements, there is nothing like that. There are no for loops. It's just print and output text and input text. You see that there aren't even variables. So to repeat what the user just put in the ask, they have to use the echo command. In level 4, now I've changed the rules. Now you have to use quotation marks. You have to use variables. So now ask commands change to name is ask. And in the print, you have no echo anymore. So you have to put the variable inside the print. So what this means that the kid knows that a more complex syntax equals a more fun program, because I can do more things. In the first level, it's really limited. I could not really do a lot of things. But in level 4, there's a plethora of things and stories I could create because the syntax allows me to it, because it's more complex. In level 18, we end up programming in a valid subset of Python, which is our objective. We want them to nurse them from not knowing programming until they know a little bit of Python, so they can move to learn Python after they learn Hedy. This is another concept. This is the concept of repetition. First, again, the concept is introduced as a real simple concept. I only allow for the repetition of only one instruction. So here is only repeat 3 times, print, Hedy is fun, cool. But that does not really allow me to do a lot, right? I want to repeat blocks of commands. So in level 8, I changed the rule. And now you have to use indentation, and now you can print and repeat several instructions. Of course, that makes the level more complicated, because now I have to worry about spaces. But that allows me to make more fun programs. Now I can repeat a lot more things. In level 11, the rules change again. And now you have the repeat is substituted by the for loop. So now it's for number in range. So it's very similar, and we're getting to Python eventually, just that we don't have brackets or parentheses here. And it's important to note that the syntax of level 11 is not compatible with level 8. So essentially, each level is its own mini programming language that it's built on top of the previous one. Cool. So that is gradual. But what about multilingual? So we ran a study, and we told kids that, kids told us that they loved Hedy, but they wanted to program in their own language. And to us, this was a little bit surprising, because they were Dutch kids. And Dutch people, they know a lot of English. So it's a little bit surprising that they wanted to program entirely in Dutch. But it's not that surprising when we think about Arab kids, or Chinese kids, or Venezuelan kids, where perhaps knowledge of English is not as common, or they use a different type of script. And for example, if I'm trying to teach print to an Arab, I not only have to teach them about parentheses and quotation marks, I also have to teach them what a P is, what a R is, because they don't know it. And they even have to learn about changing from Arab to English, and it's a mess. So now Hedy is available in 56 languages, and you can see it here in Spanish, Arab, Japanese, and German. So what essentially happens here is that the keywords are substituted by the ones equivalent in their own language. And we can also support different numbering systems. So if you are an Arab kid who does not use the Latin numerals, but uses the Arab system, they can entirely program in their own language, which is really exciting because they don't have to learn yet another thing in order to learn programming. Cool, so that's it for multilingual. But what about built for teaching? So programming, learning programming when you are alone in your room allows you to learn a lot more at your own pace. But if you're a teacher teaching programming, you want help in order to do that. And Hedy offers that not only by being designed in a level-by-level basis, so it offers a step-by-step guide, but we also offer a whole system that helps teachers in their task. For example, let's contrast it with Scratch. And Scratch is designed for someone who is learning alone, because this is a blank canvas. So me, as a teacher, I have to think, what can my students build? So I have to think about the lesson. I have to research what are the appropriate lessons. And after I design or find one, then there will be the kid who says, what can I do now? Teacher, can you help me? And that's fine, you go and help them. But after you go and help this kid, there's another kid in the opposite side of the classroom who just built this. And he says, teacher, can you help me here? I need to debug this program. So now you have to understand this code is complicated as 5 other kids are trying to ask for your help. So it's not easy. So what Hedy offers is that it puts kids in a sandbox. So if you are in level 5, the complexity of the programs we can build is limited. So there will be no kid trying to program something really complex in level 5 because the complexity of the programming language itself does not allow it. At the same time, we offer ease of use with adventures which are like the lesson plan, classes, quizzes, etc. And all of this is customizable. So if you are a teacher and you don't like or examples or exercises, you can build your own. So there is no limit in that regard. Cool. So now let's talk about the architecture of Hedy. Hedy uses a really simple client-server architecture where the programs are written in the client in Hedy, then are passed to the server where they are transpiled to Python. When they are transpiled to Python using Lark, we then send them back to the client when they are executed there using Sculpt. Sculpt is a library that turns Python to JavaScript, and then that JavaScript is executed inside of a sort of a virtual machine created in JavaScript. So let's see, what are some architectural challenges? Because there are not many programming languages that are 80 mini programming languages and support 56 languages. So we have to face a series of challenges that we have to overcome. One of them is that we used to use this editor called ACE. But ACE doesn't really support right to left languages. So people speaking Arab and other languages, they were having problems. So we have to face the decision. Do we want to devote ourselves 1 month or several weeks to replace this? So we said yes, because we want to be as accessible as possible, not only in the language, but also in the entire UI system. So we replaced it, and it was hard. Why it was hard? Because we had to maintain 18 different of these. These are EBNF grammars. So what essentially you have to do is that we have to maintain 18 different mini grammars that are built on top of one another. So how do we get to level 18? First, we have to build the grammar of level 2 by merging the grammar of level 1 with the grammar with the changes of the grammar 2. So once we merge them together, we have a full grammar. And we go and we do this progressively until we reach the desired level. We have to modify a little bit of add our own flavor of EBNF, where offering us more facilities for this grammar merging step. And in the side of in the front end, we also have to maintain grammars for that because they don't use the same parser generator, right? There is a parser generator for transpiler and another parser generator for highlighting. So we have to do all of that with 18 different levels. Okay, so what about open source? So I am Venezuelan. I come from Venezuela. I work in a Dutch project. So how the hell am I here? And it's a fun story. Because Felina started this project in 2020, and in 2021, I was just completing my programming language course, and I wanted to put that in practice. So I contacted her in Twitter, and I say, hey, might I help you with your programming language? I don't know a lot, but I might be of use. And she told me, yes, of course. And she arranged a meeting with me, and she told me about how to use GitHub and what issues I might choose. So she was very helpful, and that was impressive to me because she was a researcher from a high top university in the Netherlands, and I was a nobody from Venezuela, and she helped me. And what this means is that we as a project are try to be as open as inclusive as possible. We try to include everyone in our project, and that also stems from our own system design. There are places in our system that is not as complex as it might be because we want students to be able to use our project and develop in it and in the easiest way possible. So sometimes that means more hurdle to us maintainers, but to them it's easier because they don't have to set up a complex project. And if you want to get involved with us, you might do so by joining the Discord link here. You might go to the GitHub page, and you, of course, might visit hedi.org. You might help us by just joining there with your ideas, book reports. You might also translate from English to your own language. So yeah, thank you very much for your time. And I hope to see you in our Discord server.
Thank you, Jesus Pillay, for a wonderful sharing. If you would like to discuss with our speaker about this topic, you proceed to the social area outside. The next session will be Cyrus Wong and Lau Mei Yan at 11 a.m. and they will be talking about Azure Adventure, a RPG game to test students' Azure practical skills. Before the end of this session, we have an announcement.
So, ladies and gentlemen, I have a few exciting announcements for you. So first, at 4:30 p.m., we'll have a lightning talk session. This is a fantastic opportunity for you to share your ideas, projects, or insights in a very brief, engaging format. If you're interested in participating, please sign up at the registration booth. Don't miss out on this chance to showcase your knowledge and connect with others. Secondly, as we wrap up our day, we'll be holding a prize lottery. Stick around for a chance to win some amazing prize and celebrate the end of a productive day together. Thank you, and enjoy the rest of the conference.
Good morning. Coming up next, we have Cyrus Wong and Long Wei Yan to share about Azure Adventure, a RPG game to test students' Azure practical skills. Please give them a big hand.
多謝大家。咁啊，呢條廣東話 channel 嚟嘅，唔好意思啊，即係頭先呢樣。嗱咁啊，嗱今日我哋會講嘅 topic 就關於我哋學校做一個其實一個 project， 其實 assignment 嚟嘅啲學生功課嚟嘅。咁我哋就有個 engine 就攞嚟計分啦，帶俾一隻 game 嚟。咁我就有介紹先啦。咁我係 Cyrus Wong 啦。咁其實我就係香港資訊科技學院嘅高級講師。咁可能大家唔係好知道香港資訊科技學院。幾不咧？因為其實之前我哋就叫做 Ivy 嘅資訊科技啦。咁其實而家咧，我哋就重組咗同埋加咗啲新嘅嘢落去之後，即係我哋就變咗新嘅院校。咁都係 under 一個即係我哋 VTC 其中一個 member institution， 即係其中一間嚟。咁其實我係 Microsoft 嘅 MVP 啦，所以今日講 Azure 啦。不過其實我都係Amazon 嘅 hero 咁同埋Google Developer Expert 嚟嘅。不過今日我哋嘅 focus 就講下 Microsoft 咯。咁啊，今日比較少人講。咁啊 Mandy 咧就係我個學生嚟啦，可以企翻出少少係咯。咁就咁其實佢哋就係即專修雲。而家我搞緊 course 係雲端系統及數據中心管理個文憑，就專讀Azure 啦、AWS 啦同埋 GCP 嘅。咁啊多埋 Red Hat 啦。咁其實個背景啦，咁我哋今日第一件事會講下個問題，跟住講下隻 game， 跟住 show 隻 game 你哋睇下啦。咁啊唔會即刻打嘅。咁跟住介紹下用咗啲咩 Azure 嘅服務啦。咁跟住係點 work 嘅咧？點 deploy 咧？最後就少少 Q&A。嗱，咁其實個問題係乜咧？好認真講，你教育，你教大仔同細仔分別好大。你教啲好大嘅大人咧，其實你啲嘢悶啲咧，都 work 嘅。但係如果你教啲好似我啲學生咁，成日好多都好轉嘅，即係有啲真可能18歲、19歲咁都係細路仔，咁同埋都係好中意玩嘅。咁如果你教啲嘢雖然好有 value， 但係事實上係好鬼悶嘅咧，咁其實到結論咧，你都係失敗嘅，因為其實佢哋都係冇心機學，或者抄功課啊，點都好啦。咁其實兩個問題，我就唔希望佢哋唔好玩啦，同埋我要仔細啲去度嗰啲學生嘅技能，唔係做到係必然嘅，我要知邊個做到先，呢個係重點。即係個學生實做到嘅，一個做完教第二個做㗎啦。咁但係我要知道邊個係第一，邊個第二，第一個同第二個爭幾遠，我要度呢啲嘢。咁所以我就需要錢。嗱，咁其實所以個重點就係咧，一個成功嘅 training 啦，一定要好玩啲嘅。如果太悶嘅話，你啲嘢幾高質都好，其實到最尾你嗰啲睇你教啲咩人啦，你教啲係比較 junior 嘅，咁其實都係唔 work 嘅。嗱，咁好啦，嗱，咁其實呢個底咧有2-3個 project 拼埋一齊嘅。不過今日我哋就 overview 咗幾個 project， 但係就唔係好 deep 啦。咁其中一個係呢個喺 Microsoft 上面嘅GitHub嘅，即係你話香港人有冇人上到 Microsoft 嘅 GitHub 咧？係有嘅，係喺 Microsoft 上面嘅 GitHub 嚟，唔係 under Microsoft 嘅 GitHub 其中一個 project， 就係一個叫 Azure 嘅 Automatic Grading Engine。咁其實早期第一個 version 嘅時候咧，就係呢一個就係用 serverless 嘅角度去自動 assess 啲學生究竟做唔做啲 lab 嘅，即係啲練習做唔做到，逐個 step 做。咁但係咧第一個 version 咧就純 API call 就唔好玩嘅，完全 OK， 完全唔好玩嘅。咁但係咧就支援任何嘅 Azure training 嘅。其實嚴格嚟講咧，任何人都裝得，因為本身咧學生想玩 Microsoft Azure 咧，其實有個叫 Student Subscription， 每人有$100美金每年咁嘅，好似而家200添啦。咁其實有個 EDU 尾 email， 佢就可以玩 Microsoft Azure 1年，咁唔使錢。咁即係唔係咁唔使錢啦，俾個 limitation 你，但係就好 function 嘅。嗱，咁好啦，咁跟住咧，其實喺早期起好咗個引擎之後咧，咁就第2、第3年都開始諗啦。喂，可唔可以好玩啲啊？咁好玩啲，其實我哋就將個 project 咧就做翻一個 user interface。咁個 user interface 就唔好做個好悶嘅 user interface 啊，做隻遊戲啊，好似任天堂咁嘅。咁啊，整隻 RPG game。跟住等啲學生咧喺隻遊戲入邊打住機咁嚟攞啲題目做，跟住真係喺呢個 game 入邊要攞到錢或者攞到分咧，就唔係喺隻 game 入面玩，就係 set 你個 Microsoft Azure 嘅 infrastructure 要 set 到啱。 啱你就有啲 cons 啦，即係 game 即係遊戲同埋個現實世界就合拼咗，就黐咗落 Microsoft 嗰度。咁咧睇下隻 game 咧幾得意嘅，咁而家 show 一 show 啦。好，咁啦。
撳開始啦，咁你記住，你撳開始嘅時候咧，
好老人家覺得好
我哋呢度咧，
任天堂
後邊其實就即刻就會 call ChatGPT， 然後咧就
係啦，仲有 ChatGPT 嘅會解釋。
咁人啲題目都有機會唔同嘅，因為其實有啲 caching 咧，可能間中會一樣，但係你成日都會唔同，因為幾個字之後你再 load 隻 game，啲題目又會唔同晒，因為我哋用 ChatGPT 幫你 generate 啲題目出嚟，咁變咗人啲題目都會唔同。咁其實咧就好正經嘅啫，你而家你玩嘅遊戲啦，咁你入去啦。咁其實咧第一件事教下你先，教你個秘訣。嗱，咁你要揾本魔法書讀下佢嘅。你讀本魔法書咧，其實咧佢就會 reload 翻你啲 cons， 所以你開隻 game 咧，你想睇下你上次打落隻 game，我唔識 load，我冇同你自己 load 嘅，咁你就去翻 load 翻啲 save 翻嚟。咁 load 完啲 save 之後啦，咁其實即係冇分啦，咁冇分就做第一個 task 啦，咁你就揾啲人傾下偈。咁捉住度有講嘢，咁就勇者佢當你佢就會問你，可唔可以幫我 create 啲嘢咁樣嘅，咁佢就會同你講，你喺香港咧創建一個 resource group 俾我，冇辦法，咁你見到佢有好多 emoji 啊咁同你講嘢，咁你而家你有2分鐘時間嘅，咁你2分鐘時間內咧，你就要做呢個任務，就開你個 Azure account，然後 create 個 resource group 喺香港咩 region 你要上網 check 咯，咁你而家2分鐘時間可能你做唔切㗎，你做唔切冇問題嘅，你再問多佢一次，佢就會再同你做嘅，即係其實你再唔係 refresh 行一次一樣嘅啫。總之你就可以再行。咁而家咧第一件事咁就冇乜嘢搞住，要等一等先，因為你時間咧你見到有 instruction 有2分鐘啦。咁你撳個 park space 就 OK 會走。咁但係你走唔走冇分別嘅，都係2分鐘就同你計分嘅啫。咁你計到分應該就見到 cons。咁其實我做咗，所以而家等一等先。咁隔咗2分鐘啦，就見到啦，攞咗10蚊啦。咁其實咧你可以嗱，咁其實我係攞20蚊，咁我做咗2次。嗱，咁其實你而家你玩完晒㗎啦。咁最主要就係咁啦。咁其實識得 reload， 你記得重點記得係冇話需要 save 啦 ，check 下嗱，咁你重點嘅 check 下有冇 log in 落錯啦。即係你個 user 你唔係 Ivy 嚟嘅，你計唔到分啦，你會見到話 not member 啦。咁到最後就仲有啲 instruction 你可以試埋嘅，即係你話如果我真係 log 錯咗點做啊？log 錯咗你可以試下個 document 嗰度有條 log out link 咁，其實就係 offend 點 log out。咁你攞個 offend 點 log out 咧可以試一試咁，其實咧你就會登，即係你衰咗你可以登出嘅，因為即係冇問題。
嗱咁咁其實而家到阿 Mandy 幫手介紹下我後邊用緊嗰啲 technology stack 係啲咩嘢，你啲服務係啲咩啦？
好，唔該晒 Sarah Sir。咁我係 Mandy， 大家好。咁而家就介紹翻少少我哋用咗嘅一啲 Azure 嘅 service。咁首先呢，我哋就第一樣嘢就用咗個 Azure function 啦。咁其實 Azure function 佢重點咧就係佢係一個 serverless 嘅 solution 啦。咁其實我哋隻 game 咧，佢所有嗰啲 logic 咧都擺晒上去 Azure function 嗰度。係咁其實將我哋啲 source code 擺晒上去，然後當佢有 event， 咁其實用 Azure function 佢最平嘅一種用，咁即係有幾個 request 計你用咗幾多時間啊，跟住用咗幾多 memory 呢啲咁樣。咁我哋用咗呢個 consumption plan 之後咧，就其實成個 application 嘅 cost 咧都變到可以好平咁樣咯。咁其實仲有個原因點解我哋用呢個 consumption plan 咧？因為成個 application 嘅其實都冇話好。咁可能講緊上限可能係1分鐘啊、半分鐘左右咁樣。咁我哋係唔需要特登去開一個 server 咁所以就唔需要去揾嗰啲一啲咁嘅service app 嘅嗰啲 plan 去用啦咁樣。好，跟住講下呢個 event trigger。咁其實我哋個 application 咧，佢主要就係用 web API，咁間唔中就會用下啲 scheduler 咁樣。咁其實佢話發生啲 event 咧，其實就即係個 web call 啲嘢入嚟咯。咁佢 call 入嚟之後就會行我哋嘅 function 咁樣。好，跟住我哋就都用咗呢個叫做 Azure API Management 嘅嘢。咁其實好重要一樣嘢咧，就係希望可以 check 翻有邊個人係 call 呢個 API 啦，同埋我哋希望保護翻呢個 API。咁即係我哋需要控制下個速度。咁其實控制速度咧，都係我哋即係平時用 API 一個好 common 嘅一個需要嚟嘅。咁我哋 你見我哋而家用咗呢個 API management 呢一個嘢，就係話佢每一條 API 嘅 key 咧，咁佢每一個限定嘅 IP 咧就每60秒呢度，每60秒就淨係可以 call 60次咁樣，咁我哋就限定咗佢速度。跟住呢樣嘢就係我哋用咗一個叫做 CDK-TF 嘅嘢去 build 我哋嘅 application。咁其實 CDK-TF 咧即係 CDK Terraform。咁其實我諗好多人都用過，即係寫開 Terraform 啊。咁呢個 CDK Terraform 嘅 framework 咧，我哋有機會可以再介紹下。咁而家簡單啲講下咧，就係你見我哋而家係用緊一個 TypeScript 嘅。咁其實用咗 TypeScript 之後咧，我哋就可以即係可以用一個 OOP 嘅角度去寫咯。咁你見我哋之前即係我哋 create 咗個 API management 啦，咁樣。咁其實佢背後可能仲有好多嘢。咁但係如果我哋即係將個 program 寫完個 program wrap 咗落去個 function 之後咧，咁就可以用個 OOP 嘅角度去寫咯。咁即係話嗰啲 inheritance 啊，嗰啲multi-platform 咁嘅嘢，全部嘢都可以寫到。咁其實我哋就係用呢啲 OOP 咁嘅角度去 create 我哋個 cloud 嘅。好，咁最後我哋用咗一樣嘢就叫做 Azure Static Web Apps。咁其實我哋嗰隻 game 咧係一個 React.js 嘅一個 application 嚟嘅。咁其實佢就唔需要行其他嘢嘅啦，所以我哋直接將佢放咗上去 Static Web Apps 嗰度，跟住就用一個 GitHub 嘅 action 去做翻個 CI/CD 嘅 pipeline 咁樣。咁其實成個過程都好簡單，有機會可以再講下。咁而家講翻 Static Web Apps 呢樣嘢，如果你用好簡單去做一即係 single page apps 嘅嗰啲 React 啊、Vue.js 咁嘅嘢咧，咁你打晒所有嘢之後，然後再 sell 埋啲 GitHub 啊，跟住就用個 GitHub action 可以 deploy 到你嗰個 website。咁同埋你佢背後咧就支援好簡單。咁呢個就係我哋嘅流程咯。咁我哋寫完個 program 之後，就將佢 commit 上去 GitHub， 然後就用 GitHub Action 嘅 workflow 去自動 deploy 上去 Azure 咁樣。好，跟住呢一 part 又交翻俾 Cyrus 講。
咁啊，講翻多啲 detail 啦。嗱，咁啊，第一件事其實後邊都幾多嘢，因為其實係3隻 open source project 拼埋咗我哋，即係 Microsoft 有2個 repo 啦，一個就係嗰個 engine， 一個就係個 engine assignment。咁啊，其實就係 suppose 我哋 open source 晒俾全世界，你啲老師想裝呢套嘢或者改隻功課都得嘅。OK， 改隻功課，因為其實我後邊做嘢就係用 Azure function 去行 unit test 啊。即係，但係如果 unit test 係 test 啲乜咧？係 test 啲 cloud 嘅 configuration。OK， 嗱咁我哋有個叫做 grading engine 啦。咁個 grading gen report 啊，儲啲 key 啊 whatever。咁再 decouple 咗一 part 出嚟，其實就係嗰個叫 assignment， 因為 assignment 可以好多隻嘅。咁但係我哋之間就其實用 Azure function API 就咁用 web 即係 HTTP 咁 call 佢啦。咁啱會解釋嗰啲複雜嘢。咁最後一個 part 咧就係其實隻 game 啦，隻 game 就係用咗 static web apps， 跟住就用 Active Directory 去落現啊，咁就下滑坑落現。咁啊3部分啦，最student 註冊個戶口，因為其實啲 Azure account 咧 student 一個 subscription 嘅，因為 Microsoft 俾嘅。咁跟住 Grader 其實就真係會獨立運作。咁呢個都有啲複雜嘢嘅，因為其實咧唔係一件咁簡單嘅事情嚟，後尾做咗好耐。即係呢個我講得直啲，呢個係 hack 嚟嘅。咁點樣可以一個 Azure function 入邊行 unit test 咧？唔係咁直接嘅，因為呢個我用緊 C# 咧，好怪嘅發生。咁其實我要 prepare， 咁真係喺做嘅期間咧，我發現咗你冇辦法將你嘅 source code 包喺個 Azure function 入邊行 end unit 嘅，因為 end unit 其實係會入邊應該有啲 static variable 嘅，炒到飛起嘅。咁同埋 Azure 其他一啲 serverless 有少少唔同嘅，當年即係而家都好似好一啲，因為之前我早期做係 in process mode， 其實佢係其實 function 係一個 IIS 入邊行緊嘅 program 嚟啫嘛。咁所以如果你啲嘢真係掂到 .NET library 咧，其實係 有啲古怪現象會發生，係會 corrupt 嘅，即係你平衡 parallel 咁衝。咁我會解釋點解會 parallel 嘅一間。咁其實問啦，喂點樣可以 read 到個學生個 account 咧？咁嘅，其實個流程就好簡單嘅啫，因為 Microsoft 會好多免費 account 俾學生用。咁我哋就用 Educational Hub 啦，呢個 beta 嘢，其實你哋冇得用，因為我同美國喺度夾緊嘅。咁其實每學生派多 subscription 之後，我要 read 到個 subscription 入邊嘅所有 resources 啊。咁我哋就叫佢 create 個叫做 survey principle 即係其實簡單你好似 key 咁啦。咁有個 JSON 有啲 key 咁擺晒裏面，咁俾個 read down mode 我，咁我就可以 read 晒啲學生 account。咁總之佢就 submit 翻嗰個 JSON 上嚟，有個 survey principle 俾我，咁我儲起佢咧。咁其實背後個邏輯咧就係拍隻 JSON 落去行 unit test 嘅 executable。咁有 CCTF 好東西嚟嘅。咁跟住其實咧，其實會用嗱咁sharp 嘅attribute 啦，即係 decorator 啦。咁啲 task 寫喺上面嘅。咁寫埋啦，要做幾多分？嗰陣時 group 做1，咁其實咩意思咧？因為我後尾做咧，其實我可能用 multiple 嘅 unit test 咧去做一條 assignment。例如我要 check 佢喺香港嘅 resource group 啊，呢個就係第一條啊。第一條題目，香港有個 resource group 就係咁多。咁呢度咧其實跟住用翻 C# 去寫 reflection 咧，我可以 read 翻 attribute 出嚟 gen 翻個 game logic 出嚟。咁所以其實咧而家個 case 咧。就係其實我要 extend 隻 game 咯，我冇我啲 attribute 度打，跟住就用即時，即係其實總之 update 咗佢就會用 reflection 去 update 翻啲 task 啊。嗱咁其實 overall 我 recap 個 engine 就係一大嚿嘢啦。咁但係咧其實而家呢個 version 咧，頭先你都見到我講 ChatGPT 嘅。咁其實咧我哋用 Azure 嘅 OpenAI ChatGPT 咧做咗一個，因為其實個問題就係啲學生抄即係抄好合理嘅。咁如果條題目完全一樣咧，咁就好易抄嘅。咁就好簡單啫，每一條題目都叫 ChatGPT rewrite， 每次都 rewrite 咁滯。咁變咗其實啲學生做緊文嘅時候咧，佢就會不斷咁變嘅，即係個文法會不斷咁變嘅，即係你係會比較難 capture，同埋好玩好多嘅，因為可能你今日做呢條題目同聽日做翻呢條題目個文法已經唔同咗，不過背後意義係差唔多嘅。咁點寫嘅咧？提翻先隻 game 咧。講得直啲，真係抄翻嚟嘅，因為有個 blog post 有個朋友咧就寫咗個 React 嘅 RPG game 我哋就攞嚟改嘅啫。咁真係唔係由，因為 game 唔係我哋嘅 focus。好嗱，呢個就係個 magic 啦。喂，點樣搞到個 assignment 咁得意啊？咁其實個玩法就係，喂嗱就寫條咁咧，你而家有個 game designer，你就要 design 啲 dialogue，一定要得意嘅。OK， 即係你同佢講得意好緊要嘅。咁你記得啦，你淨係嗱咁你要講啲嘢，你唔好講其他嘢。嗱，我哋係做緊 Microsoft Azure 嘅。OK，呢個重點嚟嘅，咁我冇講其他嘢嘅。咁跟住就係個 system prompt， 即係 system prompt 咪簡單啲嚟講就係一定要跟嘅 guideline 啊嘛。system prompt。咁跟住下邊啦，喂就 detail 啦。嗱，你要重寫我俾你嘅句子。第一樣嘢 technical terms 唔好改。喂，因為呢份 assignment 嚟嘅 technical terms 嚟 resource group 咁。function 咁唔改得，因為你同佢講唔好改啲 technical terms，要做 task 嘅。但係咧有咩重點啊？一定要好玩，同埋咧你要代入勇者呢個角色，即係你講嘢咧就叫個勇者做嘢啊，得唔得？即係你見到全部都係勇者咁樣嘅，咁會同個勇者叫勇者做嘢，同我出中英文呢個重點，全英文出中文啊，做晒兩個 version。問，然後咧 rewrite 嘅時候咧。齋 rewrite 啦，唔好講其他嘢。咁跟住咧就拍嗰個題目啦，條題目就拍喺底。咁咧其實有一種想佢 random 得勁啲咧 ，temperature set 到0.9，就會創意高啲，咁佢就會不斷咁轉啊。咁其實咧有講 grader 同埋個 engine 啦。咁其實 technically 頭先解釋個 grader 其實後邊行 unit test 啦。咁但係嗰個玩法咧，到最尾。解決嗰個狀嗰個問題咧，個 process 啊，整隻 exe 出嚟，用個 Azure function call 個 exe 自己行。咁本身 Windows 啲 exe 咧就唔撞嘅 ，OK。 咁就解決咗 parallel 嗰個炒個問題啊。嗱，咁我哋咧後邊啦，有少少啦。咁其實個遊戲咧就變咗咁，每一次有一個學生要計分咧，就會開一隻 EXE 喺度行。咁啊又唔係好大食嘅，咁就結果就做得到 parallel run 嗰個 solution。因為之前開頭試係 corrupt，個 parallel 咁 call 啲 abstract function，佢會發現佢會啲 result 係會撞嘅，佢又唔係 error，佢會錯嘅，好得意嘅。咁但係我覺得可能關於 N unit 個 library 入邊問題事。但係所以而家咧個 N unit 就抽咗出隻 EXE 出嚟，咁其實就開心大發現，其實你可以喺個 Azure function 入邊再行其他嘅 program 嘅，你只要將成隻 program 抌咗上個 share drive 度掹咗佢咧，咁佢就做乜都得嘅。咁今次呢個就用 Windows 做，因為 Windows platform 嘅 Azure function， 我係用緊 consumption plan 嘅，最得意就係嗱咁個界面就好簡單嘅啫，擺條 key save 咗佢或者 run 下啲 test 啦。咁其實喺個底咧就行一個 command， 即係喺個 Azure function 入邊行 command line 啊，咁就行呢個 EXE 叫佢 run 測試，即係個邏輯就係咁。嗱咁其實咧又有啲 schedule job 嘅，例如啦，喂，然後每晚12點同我 check 下啲學生分數啦，因為我想每晚 check， 又實時又記錄，每晚又做個 report 俾我，咁就用即係 Azure function 個 timer 嘅 trigger 嘅，咁用個 timer trigger 每晚咧就同我做咁樣嘅。其實可以 configure 好多個 task 嘅，所以其實咧我哋用 regular 用嗰啲 cron job expression 去做。OK， 嗱咁啊呢啲就係啲 output 啦。其實咁啊底咧我就用 table storage 嗰個玩法去搞，咁就整條 partition key 就啲功課，跟住揼條 link 就 call 出去啊定義功課嘅方法。咁幾時改一次，咁你就整個 cron expression 幾時改一次，咁佢個底嘅就會行啦。send 唔 send email 俾個老師 ，send 唔 send 分俾個學生，咁啊 configure 呢啲咁嘅嘢。咁後邊會 send email 俾啲學生嘅啫，今日幾多分咁樣。嗱咁呢度咧就係嗰個 magic 咧，就係 parallel 嗰個 magic。嗱咁我咧其實咧用咗其實用 workflow 去做會比較好。其實咧你諗下，你寫 program 比較複雜啲，你想用啲，仲有講啲 limitation 嘅就係如果你想啲嘢平衡行咁點啊？咁其實就用呢個叫做呢一個寫法啦，又用咗個叫做寫入面你可以做一個 orchestra。炸 Azure function 平衡咁爆出去，呢一個寫法啦，因為用個 parallel task 去做，然後再 wave 佢，咁就公道啲。因為其實如果你改學生功課，你冇理由一個先一個後噶嘛，你梗係要 parallel 啦。你如果你有人先有人後，咪唔係好公道，我哋鬥快嘛。呢份功課係鬥快，如果要包尾改，咁咪好蝕底。咁就係咁做嘅。咁其實跟住啲 result unit test 咧，其實行完啲 XML， 我哋儲起晒喺呢度啦 ，story account 啦，儲起晒佢啦，然後定時定候就 pass 翻佢出 Excel 啦。咁跟住嘅 grade report 又係定時定候 trigger，佢就整翻啲 grade report 出嚟啦，就抽啲學生 performance 出嚟。時間差唔多，我快啲咧就話，其實咁我哋驚佢抄功課，咁就冇得抄功課嘅，因為個學生個 share 個 Microsoft Azure account 咁有機會，係咪先？咁咧所以一定要記錄晒嘅，就要錄低晒佢個 subscription ID，map 咗個 email。有人用咗嘅唔准再用，咁就冇得 share account 啦，即係 share account 要避免。好，咁啊，跟住 deployment，CDKTF 係樣好東西嚟嘅。如果你唔係用 Amazon，我可以答你呢件嘢最好。OK， 如果 Amazon 就 CDK， 唔係 Amazon 就一定係 CDKTF 嘅。咁我而家我要 deployment 咧，我好簡單啊，即係你空我個 repo 出嚟 ，install deploy auto approve done， 搞掂噶啦，成套嘢會出晒街噶啦。咁啊，如果 deploy web app 咧就特別啲，因為嗰個 web 個 application 咧就 Azure Static Web App 啦，咁其實就用 command line 去做，咁啊幾句 command 就 deploy 到噶啦嚇。好，咁啊呢度就係 Static Web App 嘅 command 啦，咁啲 show 少少啦 ，resource group 指住佢邊個 GitHub repo，咁佢會幫我哋 create 埋個 GitHub action 又好正嘅，咁你以後咧再 update 個 web application 咧，你就 commit 上 GitHub 得噶啦，佢 CI/CD pipeline 自己搞啊，唔使搞，所以好方便。好，喂，咁啊〜時間啱好啊嘛，好，咁而家就 Q&A 時間啦，問題啦 ，OK， 時間啊，係啊 ，OK， 我唔知啊，我唔睇啊，中午幾好舉，係咪就係舉牌啊？差唔多，我幾耐睇唔到近視，15分鐘啊，5分鐘，嘢，哦呢度。就冇睇嘅，即係呢個機搭住咗我。OK， 哇，好似冇喎，冇咁緊要，冇早啲完。啊有啊有，hello啦。其實啲學生嘅，有啲學生係可以一掟出嚟嗰晚就做完咗，實時咁個計分噶嘛。但係有啲真係做到學期尾咧，都仲未完成到咁樣嘅。咁啊，即係有好似即係其實即係頭一尾嘅戰鬥力咁，但係亦都冇乜所謂嘅。咁但係跟住再寫 unit test 去 test 翻個 ideal 嘅 infrastructure 係點，跟住逐 group 咗啲 unit test 嚟睇下幾多個 test 過到，又俾幾多分佢咁玩咯。咁其實好好嘅，因為第一件事咁做咧，學生又可以知道自己嘅分，我又唔使改，即係我做一年金地寫鑊金嘅 program 之後，相對上就係之後嗰幾年啊啲同事都唔使點搞，係啦。OK， 有冇人有興趣問？hello 啦，係。唔會嗱，因為咧其實咧呢度冇 show 曬 source code，其實頭先嗰個 JSON 咧 gen 出嚟嗰度咧有個 order 嘅，即係其實咧嗱，應該講真唔可以 random 嘅，因為呢度呢啲唔係真係普通 MC 題目。而家我哋做緊啲題目咧，其實係其實有次序嘅，即係正經啲嚟講，喂你不能夠起咗個你叫人開個 Azure function， 然後先至起翻個 resource scope 係唔 work 噶嘛，有次序噶嘛。所以咧其實呢度 game task 咧係有個priority 㗎，呢度有個 game order 嘅。呢個 game order 不過個界面咧縮咗啊，因為有個 class 啊，個 class 個頂係有個 order 嘅。咁但係咧就因為個界面 show 唔到咧，就變咗得個 group number。咁其實咧正經嚟講咧，其實有個 game order。咁但係同一個嘅 game order 就有機會 random，因為例如有啲嘢可以整先整後冇乜所謂嘅，就會 random。但係其實隻 game 即係咁講嚟講，我哋隻遊戲都係帶住個學生睇下佢，即係其實我都俾埋，即係你上網慢慢睇啦 ，open 咁做。總之你做得晒佢就得㗎啦。咁即係目標係咁嘅，即係唔係話即係差，即係唔係話頂到佢做唔到咯。係。唔係打工，係你有個 Azure 嘅 account， 你要 set 到個 ideal 又安全又有效率嘅 cloud infrastructure 俾我。咁我大嘅冇 program 嘅，我係預佢 set 個 cloud 嘅。咁佢可以打 program set 個 cloud 嘅，我唔理。但係其實ideal case 係我會。其實我就 assess 佢個雲，即係個雲上邊嘅 knowledge 同埋佢識唔識 set 嗰啲嘢，我唔係好明顯咁講呢件 instruction 嘅。咗嘅咪冇分咯。咁其實係一啲咁樣嘅嘢啦。係好好問啊。係啊。空其實老答你，佢唔係寫高，但係寫高人做咧都知嘅，因為 real time 咁慢嘅。咁其實如果你突然間嗱，即係講真句，我就 suppose 有啲位係手撳，即係講明個 game 玩法咧手撳嘅，大家都。因為其實咧就咁啦，咁但係其實如果佢真係 program 做啲 touch form 起咁，其實你見嗰個分數突然間暴漲啊，你都即刻 check 到啦，其實死梗。因為其實重點我完全 full control 佢個 account 噶嘛，我 read 佢啲 log 都得嘅，我 read 佢 access log 佢已經死啦，佢即係死梗嘅，即係因為 cloud 咧係冇秘密嘅，乜都有 log 噶嘛，係啦 ，OK， 係咪差唔多嘅時間？等陣唔係話，其實我又冇做呢啲嘢，但係其實我 set 緊個 嘅時候，佢問 ChatGPT 點？例如我唔知香港，即係嗰人問我頭先，我叫佢 set 喺香港啊嘛。其實佢真係要上網查，咁我唔會同佢講 USE， 即係佢唔會講邊個 region 嘅。佢真係 set 嘅時候個 region 嚟噶嘛 ，region code 嚟噶嘛。咁我咪要佢上網查咯。咁但係佢之前就當上網查，但係其實佢問 ChatGPT， 我哋都唔理。總之我要佢解決到個問題啫。咁可以講多樣嘢你聽。通常我呢啲咧個 assignment 咧之後就點樣做測驗嘅？測驗就喺個 lab 度錄影佢個 mon， 叫佢即刻做一次。係啊，仲有其實下一個玩法就玩 debug。因為其實你心水清就明嘅，我可以控制個學生 account 幫佢 set 一句有 bug 嘅牆，然後叫佢 delete 噶嘛，根本就死梗。你冇得玩嘅，你唔識真係死梗，因為呢個係絕對嘅控制權嚟。係因為其實我唔係齋 read 佢 account， 我有另一個 project 㗎，不過今日冇講。我係一次過可以控制100個學生 account， 成100個 infrastructure 一齊起嘅。係啊，係做到嘅，好易做。因為其實我有辦法 pair 行車咁做嘅，不過嗰個唔係用 Terraform 做嘅，用 Azure Container 啦 Instance 做嘅，因為我用唔到 consumption plan， 因為 Terraform 10分鐘起唔切，10分鐘起唔切，所以另一個 project 就係平衡咁開一個學生一隻 container， 跟住就幫佢 create infrastructure。咁其實可以夾另一個 project 咧，做一啲叫 debug 性質嘅 assignment 嘅，嗰啲就仲刺激。係，好問得條啦。係。其實我百零人咯，但係其實咧用 consumption plan 咧，我哋點都唔會用到個 limitation 度。即係其實我同你講，我呢度用得好狠嘅。呢一個 assignment 已經唔狠㗎啦。我有另一個 assignment 咧，我用 consumption plan 不停咁 run 啲 Python unit test， 個學生每打一句 program run 一次啊。因為我話要，喂講真，你抄功課啊嘛，我就 cap 你個 screen， 你總之打字不停 save， 不停 send 啲曲上去個 Azure function 度，不停 run unit test， 睇下邊個做到先，所以邊個抄功課即時死亡。係好癲嘅，可以行到幾百條 Azure function per second 嘅，冇乜嘢嘅，但係好平嘅，因為我温得好快噶嘛，我温 unit test 好快噶嘛，如果派貨係啊。喂，時間係咪到啊？真係到就完咯。OK 啊？喂，咁多謝大家，多謝大家，係咪夠鐘？我唔係咯，差唔多負咗啦，見到。
Thank you, Cyrus Wong and Lau Mei Yan, for a wonderful sharing. If you would like to discuss with our speaker about this topic, you proceed to the social area outside. The next session will be Wei Chong at 11:45, and he will be talking about HK Bus app, free and ad-free bus app, costing $1,000 per year to support 40,000 daily users. We will start at 11:45. Good morning, everyone. Coming up next, we have Lo Wai Chun to share HK Bus app, free and ad-free bus app, costing $1,000 per year to support 40,000 daily users. Yes, let's give him a warm welcome.
Hello everyone. This will be conducted in Cantonese, but the slides will be in English. So if you can't understand Cantonese well, you may read the. 好，咁我哋就開始啦。咁啊，大家好，我叫阿俊啦，係啦，咁就喺巴士 app 嘅，咁嗰時或者講下巴士 app 先啦。咁個巴士 app 其實就個主要嘅賣點就係唔使錢啦，同埋冇廣告嘅。咁冇廣告就係冇廣告咯，就係一個咁基本嘅要求咧。我哋香港都係好需要嘅，係因為太聽到係都有啲困難嘅，咁所以我都想嘗試去做一個咁嘅 project。咁而家個巴士 app 咧，主要就 cover 咗唔同嘅交通工具啦。咁就巴士龍運啦，即係九巴、龍運、城巴、新大嶼山巴士啦、港鐵啊、小巴、綠色小巴啊，同埋3間渡輪公司，即係港九渡輪啊、新渡輪同埋富裕小輪，咁都 cover 咗。咁主要嗰啲會睇到嗰啲時間預計嚟嘅時間啦。咁至於有啲 auxiliary 嘅 data provider 咧，就係俾啲地圖啊，俾一啲天氣嘅資訊啊，或者一啲道路嘅消息啊、交通嘅新聞咁樣。咁仲有地圖上面啲 label 咧，都係用政府嘅 land department 去俾嘅，係啦。咁而用到嘅 technology 咧，咁其實都係啲比較 popular 嘅 framework 啦。因為呢啲 open source project， 即係我自己睇法咧，就會係最好就 popular 啲，因為都唔知自己做到幾耐嘅，咁就 popular 啲。如果有人想接受都可以接受嘅。咁source code 就擺呢度嘅，係啦。咁呢個大概個 outline 啦。咁而家就每年其實咧就大概用1000蚊到嘅，主要嘅錢咧都係俾喺 domain 嘅錢啦，同埋擺上App Store 啦，同埋 Play Store 嘅錢嚟嘅。咁加埋就1000蚊一年咁樣。咁大概每日有4萬幾人用啦。咁有時多啲，有時少啲。即係天氣差嘅時候就可能真係會少啲嘅。即係冇人出街，咁但係如果真係陽光普照啊，每日翻工嘅話咧，咁嗰啲日子可能都有陣時會上到5萬都唔定嘅。好，咁我哋去下一頁先。好啦，咁點解開初會做呢個 Apps 咧？咁就其實就同自己媽媽有關嘅。咁啊，自己媽媽就用一啲commercial 嘅 app 啦，咁就面對好多廣告，咁就好困擾啦。咁所以咧，咁就作為一個乖仔，咁就去寫翻個 Apps 就幫阿媽啦。咁而且當時有個好處嘅就係咁啱咧，喺2021年嘅4月咧，就政府就將九巴 data， 即係九巴嗰啲巴士到站嘅時間就開放咗嘅。當時只有城巴啫，咁但係因為我住嘅係新界九龍區嗰邊嘅，咁就主要都係九巴多啦，咁所以就想寫都冇得寫，想攞到九巴嘅資訊都冇嘅。咁到佢一開放咗而自己阿媽咁需要嘅時候咧，咁就嘗試去寫一個 Apps 出嚟，就幫到佢咧，亦都幫到自己。咁啊係啦，咁就避免咗嗰啲好 end 嘅 UX 啊，即係又要跳出嚟等5秒鐘先可以撳熄佢嘅廣告啊，亦都可以慳翻啲 data 嘅流量，因為我自己係用數據卡咧，就係限咗係得幾 G 嘅啫，嗰陣時。幾激一個月嘅啫，咁如果攞嚟撈廣告，仲有啲影片嘅話，甚至撳錯咗落去咧，都係非常之困擾嘅。咁就都係希望可以慳到時間啦，慳到錢啦，同埋慳到下即係可能呢一啲情緒嘅波動都唔需要去睇啲無謂嘅廣告嘅。係啊，咁另外啦，都係追巴士嘅時候，好關鍵就係你睇5秒廣告咧，咁就可能都 miss 咗班車㗎啦，因為起唔切跑就冇㗎啦。係啦，咁呢個就係主要個 motivation 啦。係啦，咁喺真係做嘅時候咧，咁面對住成個 problem 啊，即係做咁嘅巴士 app 嘅時候咧，最關鍵有3個challenge 啦，對我嚟講。咁就第一個咧就係要搞 multi-platform， 因為咧自己啦，我自己就用 Android 嘅，咁但係我媽咧就用 iPad 嘅，係啦，咁佢就唔係 iPhone，佢用 Android，但係電話對佢嚟講都太細啦，咁老花就唔係睇好清楚，佢係中意用 iPad 去睇時間嘅。佢已經面對第一個 cross-platform 嘅問題。咁第二樣咧就係本身自己啦，都冇信心係做一啲好 即係俾一啲好 long term 嘅 commitment，即係都怕即係寫個頭出嚟之後就跟唔到嘅，咁就所以都希望可以簡單啦，或者係揀啲 popular 啲嘅 framework，可以有人接受，起到個頭係最好噶啦，就最好後面有人跟埋佢，做好佢，做靚佢，咁就最完美啦。咁第三樣咧就係因為原本個 design 咧都係俾自己同埋俾阿媽用嘅啫。咁做一個 app 嚟講，就唔希望有俾錢揞錢出嚟 support 兩個人，咁其實冇意思嘅。即係我冇理由俾幾十蚊起個 server 嚟 support，淨係我同我媽一個每日睇巴士嘅過程。咁所以都期望就比較平啲啦，希望個成本可以低啲。咁當然就幾十蚊可能誇張啲啦，咁但係有得平就一定係諗啲更加平嘅方法嘅。係啦，咁就因此咧就有3個 target 就出現咗，咁就係第一就係 cross platform 啦，亦都要好快咁 develop 嘅。咁第二咧就係要用啲好 popular 嘅 framework 啦，咁就希望有人可以跟到上去接手啊，咁就唔使我做啦。咁第三咧就係希望可以唔使錢嘅 deployment，同埋可以 launch， 即係最好 web hosting 嗰啲包晒。係啦，咁就呢3個方向咧，咁第一個 cross platform 嘅問題咧，咁就揀咗用一個 progressive web app 嘅方法做嘅，咁即係基本上就有 browser 就開到啦。Safari 好，Chrome 好，Firefox 好，IE Edge 都好，咩都好，總之有 browser 就開到，咁就直接就 cross platform， 我就唔使去搞啲 native code 啊，整啲 native app 咁樣。咁第二就係用啲 popular 嘅 framework 啦，就用咗 React 同埋 Material UI 啦。咁我諗 React 大家都應該知道就係應該而家喺 NPM 上面喺 framework front end framework 嚟講，應該都算係最 popular 㗎啦。係咁最 popular 咁就當然係揀咗佢。第一就係我原本唔係好識咧，都可以上網揾到其他人參考啦。第二就係有其他人想 contribute 咧，都可以即刻去係啦 fit in，咁就可以開始寫啦。咁至於 Material UI 咧，雖然就唔係最 popular 啦，咁但係當時嚟講就可能我身邊嘅師兄啊，或者係身邊嘅 IT 朋友都係用 Material UI 嘅，咁就我都係貪快嘅啫，咁就開始就 Material UI。咁確實都唔係少人用嘅，咁但係都唔係最 popular。咁第三啦，就好似啱啱IIT 嗰位講者咁講，都係用啲 GitHub 嘅pages， 咁就唔使錢，咁就可以 launch 到啦。係啦，咁有咗呢個 approach 即係有咗呢3個 approach， 咁我一個 prototype 嘅咁完全係 client side 嘅政府 API 攞晒成個 database， 巴嗰啲線之後直接喺上面去砌個 database， 然之後就攞嚟用，係啦。咁個好處就係好快寫完啦，我好似3日到就已經寫完嗰個 program 啦，個 prototype 啦。咁但係個唔好處咧就係其實每次開機咧都要等20秒去做 initialization， 即係慢慢 call 啲 API 砌嗰個 database， 仲有3秒其他compression 啊、save 低 cache 好啊等等唔同嘅嘢。咁再差啲咧就係原來成巴新巴咧，當時嗰個 API 咧係會炒嘅，即係政府嗰度會因為太多 request 之後就會403咁樣就 too many request 定應該唔係403，應該401咁樣嗰啲就 too many request 就冇得用嘅，咁就所以偶爾就會開唔到咁樣，咁就非常之唔爽嘅。係啦，咁所以咧之後就揀咗啲改變咗個 solution stack 啦，咁就而家基本上都係遵從呢個模式咁去做嘅。咁就會分咗3個 repository， 即係3個 GitHub 嘅 repository。咁第一個咧就係一個叫 HKOSCon 嘅 database 啊，咁就係每一晚凌晨3、4點零鐘咧就會去 call 政府嘅 API， 咁就砌翻嗰個 database。咁佢主要做嘅就係去整合九巴、城巴、綠色小巴、地鐵啊、渡輪啊等等唔同嘅交通工具嘅資料，即係佢有咩路線停咩站。佢條 API 嗰啲 ID 係即係個巴士站個 ID 係乜？咁嗰啲全部就每晚就整合一次，咁就貨佢每日都會有啲 update 嘅，即係可能個站改名啊，有啲調咗位嘅站啊，咁等等咧都會每晚去 update 嘅，係啦。咁第二個部分咧就係整個巴士 app 啦，就真係個 front end 嗰個 app， 咁就係啦，咁就每晚有個 repository 就係專 for hosting 嗰個 web app 嘅，咁就 source code 啦同埋標好咗嘅code 都喺晒上面㗎啦，係啦。咁第三個咧就係整個 API 嘅，咁就因為配合翻啱啱提到上面嗰個 database 啊，咁其實都希望有個code 嘅 separation，咁就 for 唔同嘅其他人咧，即係其他developer 都好， 都可以用到嗰個標出嚟嘅 database， 咁就按翻嗰個 format 啦，咁就去 call， 咁就方便可能喺其他 JavaScript 啊上面嘅 development 可以用到喺唔同嘅 app 度，係啦，咁係啦，呢3個咁嘅格局分咗之後咧，就會見到左手邊張圖啊，就係部手機其實就直接連住嗰個巴士個 front end app 啦，就偶爾就會去 update 下個 database， 咁後面就會攞個 API 嘅 code 去 call 政府嘅資料嘅，係啦，咁就會得到我哋想要嘅巴士時間咁樣。好啦，咁就之後咧講完啲motivation 啊、approach 啊嗰啲嘢之後咧，咁就講下喺 development 嘅過程裏面遇到啲咩困難啦。咁第一個最大嘅困難咧，其實就係即係大家好理想就係覺得，喂啲巴士資料喺晒度黐埋佢就搞掂啦。咁但係咧實際上面對好大嘅問題就係唔同嘅巴士公司咧，佢哋個 data format 係唔同嘅。咁就尤其是係城巴而家城巴啦，咁佢嘅路線咧，就算有啲特別班次都好，佢都係按一條線咁俾啫。即係譬如偶爾佢先會停107啦，有架巴士係107，佢禮拜6日先會停海洋公園嘅。但係佢俾出嚟嘅資料就講到佢會得一條線107就一定會經海洋公園嘅。咁有呢啲問題底下，其實就要做好多整合啊，同埋要同運輸署嘅資料去做對比，咁就做翻啲 heuristic 嘅 function 先可以揾得翻，先有機會揾得翻佢嗰條路線實際上係邊一日行邊條線，同埋係點樣行。係啦，咁所以個過程裏面咧都係有好多好 tedious 嘅嘢啦，同埋啲 data 未必係 exactly 每一日都最 update，有時會 delay 2日或者3日咁樣，所以都會有一啲操作上嘅問題嘅。咁但係始終呢類咁嘅 update 或者呢啲咁嘅 data 上面嘅嘢咧，我哋用 heuristic 解決都唔會100% 嘅。咁但係唔係100% 都好，都唔會影響所有 user。咁所以暫時我哋都係用啲 heuristic 嘅方法，等佢自動化 update 到就算㗎啦。咁同埋 user 慢慢 adapt 咗之後咧，都會習慣或者知道咗嗰條線個變化係點嘅。所以咧就唔係完美嘅 solution，咁但係都叫可以繼續用到嘅。好，咁就第二個 challenge 咧就係因為我本身咧就唔係寫開 front end 嘅，係啦，我本身職業就做 bioinformatics 嘅。係咁就對住啲 DNA 玩下嘅，咁所以咧 front end app 嘅 optimization 原本我係完全唔識嘅，咁就所以一開始寫到 app 出嚟咧，其實係好慢嘅，即係都窒下咁樣嘅，咁都係用翻啲基本嘅即係睇翻啲stack overflow 啊，睇翻啲documentation 咁學翻一啲 basic 嘅 virtualization 啊，同埋有啲 context segregation 嘅嘢，咁就令到 apps 咧其實而家開出嚟大概我諗 first loading 啦，即係第一次開嘅時候個時間都會耐啲，咁但係load 好咗可以 cache 到之後咧，其實每次開應該都係3-2秒到就應該開到，可以揾到自己條線㗎啦。咁所以就算係基礎咁樣解決咗呢個時間嘅問題。好，咁就 technical 咧就應該去到呢度嘅啫。咁當然後面仲牽涉好多 technical 嘅 challenge 啦。咁但係係啦，我都知道大家都係 technical 可能高手中嘅高手啦。咁所以咧 go into 太多 detail 就未必適合嘅。咁我都會 cover 第二啲 topic 係講下啲SEO 啊或者 marketing 嗰啲嘅，係啦。咁寫咗一個咁嘅巴士 app 出嚟之後咧，面對第一個問題就係都除咗阿媽用得開心之外咧，咁自己用埋咁都覺得可以 share 俾唔同嘅朋友啊同埋 general public 嘅。咁當時候咧，咁第一樣諗嘅當然係 SEO 咁去做啦。咁就係啦，面對嘅第一個問題就係原本用 GitHub page 咧個 SEO 係做得好差嘅，因為佢個 domain name 咧就唔夠 specific。咁所以嗰度就買咗個 domain name 啦，咁就大概150蚊一年嘅，係啦。咁另外就係因為要做 SEO 咧，咁一般嗰啲教大家做 SEO 嘅方法都係用 server side rendering 嘅，咁就希望 launch 個 server，等個 Google 啊嗰啲有個 crawler 嚟到嘅時候就整一頁俾佢，等佢做 indexing 咁樣。咁但係我哋呢個 case 嗰度咧，因為冇錢嘅關係係唔會有呢個 server side 嘅 rendering 出現嘅。咁要解決呢個問題咧，我哋就用咗個mock up 嘅Chrome 咁嘅 library 咧，咁其實就係每晚去做 build 嘅時候，就逐頁咁 generate 晒每一條線佢需要用到嘅嗰個頁面係咩樣，咁就等 Google 嚟到嘅時候就有個 static web page 咁樣去做 indexing 嘅，係啦。咁呢度就係一個 SEO 嘅方法啦。咁用咗呢樣方法之後咧，其實個效果都唔太差嘅。喺過去12個月咧，其實個網站咧成個網站都有百零萬 click 啦，約略130萬 click 啦，即係一年130萬都，我覺得都算 OK 㗎啦。咁 impression 即係俾人 search 到咧都有28 係因為2000幾萬啦，係2000幾差唔多3000萬嘅impression 啦。咁但係當然average 嘅排名係8.4就唔算特別高嘅。咁但係其實大家可以想象後面 total 嘅 page 咧應該有9000幾頁嘅。咁所以其實大概8.4個 average 咧，咁其實有唔少都可能排到去第三、第四，有啲甚至第一、第二嘅。咁所以我覺得喺一個 open source project 嚟講啦，就唔係 commercial project 嚟講，冇乜 budget 底下咧做到呢個數咧，我自己覺得係滿意嘅。咁但係當然總可以精益求精嘅。咁但係呢度我就冇再特別花時間去諗或者係再 fine tune 到 SEO 上面好勁嘅，係啦。咁但係呢度都值得去share 一下啦。咁等大家知道其實一個 open source project 可能只要肯花心機做咧，都可以做到一個好嘅 impression 啊、SEO 啊咁樣嘅。好，咁之後咧，除咗 SEO 之外咧，咁都有去嘗試用其他方法去做啲 media exposure， 咁去推廣個 app 啦。咁就一開始嘅時候咧，都可能係呢個唔係我嚟嘅，係啦，咁就真係唔係我嚟嘅。咁喺連登嗰度都會出 post 咁樣，有啲人會 share， 因為知道咗之後，其實啲人都會好主動咁樣去 share 個 post， 即係可能有啲人鬧一啲商業性嘅巴士 app 好多廣告阻住晒，嘥晒時間嘅時候咧。咁都會睇到有人會主動留言去講翻，其實都有啲冇廣告嘅巴士 app 㗎啦。咁喺嗰啲時間底下咧，其實都累積咗一定嘅 user 啦。咁嗰陣時大概可能全港我哋用 Google Analytics 去做嘅時候，都大概1萬人到去用個 apps 嘅。咁但係1萬咧係低估咗嘅，因為我哋個 app 咧可以俾人揀唔落低嘅。咁我睇翻可能 Cloudflare 嗰啲真係睇個流量咧，其實個流量係大概應該係而家你見到嘅數多25% 左右咁樣嘅啫。咁所以如果嗰陣時1萬到，應該可能有13000到嘅咁嘅人數去用個 Apps 度嘅，係啦。咁之後一開始係咁樣啦，咁就之後就去開始嘗試喺啲 social media 嘅媒體，咁喺香港讀媒嗰度就落廣告啦。咁落咗廣告之後咧，大家都會見到有個 peak 嘅，係啦。呢度咧就係啦，11月嘅時候有個 peak 嘅，咁就的確咧係落廣告。其實中間之前都試過 Google 嗰度落廣告，因為同樣啦，其實我做呢啲 project 咧使少少錢就唔介意嘅，咁當係學下了解下究竟 market 點做啦。當時都會使啲3萬落個 search 嗰度咧，發覺完全冇用嘅，即係佢就會極速同消費啫。咁其實實際上會開拓嗰人咧係冇感覺嘅，咁就嘗試下其他就捐錢俾就嗰個落個廣告下啦，咁就少少嘅片，咁好卡上到3萬嘅，係啲10萬標嚟嘅啫。10萬標就翻去聖誕自己就點佢，咁但係之後就 YouTuber 就睇到係啦個報道啦，咁所以又揾我去 YouTube 嗰度講。咁之後就仲有多個採訪啦，咁都可以大概係上一上咁樣。咁整體就會係上咗之後就維持，實際上就睇下4萬啲人嘅，咁就係啦。呢出 Cloudflare 咧係因為 Cloudflare 只得1個月，即係睇得翻1個月嘅啫。咁 Google Analytics 先可以睇到一個比較長嘅時間嘅。咁我都想 show Cloudflare 嘅。就好啦，好咁就SEO 同 marketing 就大概係咁樣啦，咁就其實都係花啲時間同埋心機去做咧，其實去推個 project 都係好有用嘅。好，咁然之後咧最關鍵都想 share 嘅就係個 community building 嗰 part。咁 community building 咧就可以講下最主要嘅方法喺度就係第一就係喺啲 media 有 exposure 啦，第二咧其實最關鍵喺個 Telegram 度。咁個 Telegram group 咧，其實我自己個感覺氣氛都係好良好。而家 active 嘅 members 咧就大3人啦。咁其實個禮拜咧會出 post 嘅，即係出 message 嘅 members 都有30幾個、34個。咁overall 嘅 message 啦，咁嗰度20.9咧就係我 throughout 呢個開之後嘅message 嘅量，咁就見到300人啦。所以其實咁喺個 group 裏面其實都係好多，咁就包括有啲嘅新聞。啲 bug 嘅種種嘅嘢，其實都會喺個 group 會揾到一啲揾唔到嘅 data source 嘅，即係譬如右手邊嘅嗰條線咧， 嗰條巴士嘅路線咧，原本我就只係喺巴士站都幾核突嘅，咁就只係話俾你聽邊個廢啫。咁就係嗰條巴士 exactly 點樣行，即係條道路順埋啦。咁所以其實係好有機同埋好良性咁樣去令到佢做得越嚟越好嘅，係啦。咁個總統係真係向呢個方向做會好啲咧，咁就裏面會傾好晒，跟住先做 implementation 咁。好榮幸咁。project 啦，有好多人 fork 埋入 PR 嘅。咁overall 喺個 contribution， 即係 community 嘅 contribution 咧，其實都好大嘅。咁就有面都喺度嘅。咁佢就原本係個 web 嘅，咁佢就擺上即係佢將佢擺上呢個 Play Store 同埋App Store 上面嘅。咁就令到個受眾係更加大嘅。即係就我諗可能譬如我媽啦，我就會同佢喺個progressive web app 嗰度裝出嚟。咁但係咁就擺喺 Play Store 同 App Store。就係肯 open 呢翻譯上面嘅問題，因為即係雙語能力唔係特別高嘅，同埋有時有啲用字咧，有啲人係有堅持嘅，即係譬如路線個線字講係兩個過字啊，定係一個全字咁，其實係有出入嘅。咁裡面啲人就會去執好嗰啲每一個細字咁樣嘅。咁另外就係有啲 coding style 嘅 unification， 咁就呢個其實好重要啦，因為我原本自己寫嘅 project 咧，個 coding style 都我會同自己講 OK 嘅，咁但係唔係個個都會話 OK 啦，好明顯。咁就佢哋都會喺 community 裏面都會做翻一啲prettier 嘅 tool install 翻落去，咁就整理翻成所有嘅 code， 係啦，咁就令到唔同嘅人要 join 個 contribution 就更加容易啦。係，咁仲有就係 UI/UX 嘅 improvement 同埋 bug fix 啦，咁就呢啲都係一啲 community 會幫手做嘅嘢，咁都係令到成個 project 個推動係非常之好嘅，係啦。咁就應該仲有一啲就係 community 上面其實都會對 data 咧就會有渴望啊，即係如果有多啲 data 一定會更好。咁呢啲有啲就係我自己諗嘅，有啲咧就係個 Telegram group 裏面有人睇嘅，咁就係其實有啲咩 data 仲可以 open 咧。咁第一個咧可能係交通燈嘅幾時轉紅燈、幾時轉綠燈啊嗰啲變化，其實如果 open 到嘅話咧係有幫助，可能我哋 estimate 班車幾時嚟。係可能爭個站口，爭個轉彎位，就係等個燈後嘅啫。咁呢個係如果 open 到嘅就非常之好啦。咁有啲 signal time plan open 到係十分好嘅。咁第二個咧就係 real time 嘅巴士嘅 location。咁個 screen capture 就係喵喺 YouTube 上面一條片啊。咁就係反映到其實九巴咧的確係有每一架巴士實時嘅 location 嘅。咁但係而家當然就唔係 open data 啊呢樣嘢。咁就如果佢 open 到嘅話，咁就一定係非常之開心。咁大家可以想像，你攞住 app 就可以睇住，我嘅巴士爭個街口定係仲喺隧道，定係已經飛咗站。因為有陣時個estimate 即係個 ETA 話嚟俾你聽，啱啱過嗰站，咁係前面啦，好近係真係飛咗站咧，係唔知嘅。咁如果有巴士準確嘅 location 嘅，定係好有3D position。咁如果俾埋半去個巴士站平路咁， 最尾點嘅咁我理解應該政府或者做呢樣嘢嘅，咁但係暫時就未見到有 API open。咁如果做到嘅話，就可以更加好去做一啲路線嘅規劃，咁就方便係直接去規劃到今日原來喺港大呢度去將軍澳，究竟應該搭地鐵定係搭巴士，咁就會更加好啦。係啦，咁應該分享就去到呢度噶啦。咁仲有少少時間，大概5分鐘到就有 Q&A 嘅。有啲咩問題想問？係請。2012嘅時候，佢已經 open 咗嗰啲巴士到站嘅預報時間嘅。咁呢個就係應該係巴士嗰啲續牌咧，咁佢政府係要求佢哋要 open 呢啲 data，咁所以就令到成件事可以我哋啲公眾都 access 到。
即係而家你個 app 係而家係可以睇到，譬如係1年7號3分鐘內到站咁樣。
係啊，冇錯。唔介意啊。As the project itself is designed for cross-platform and is initially a web app for high school student or maybe newbie in coding, he or she may follow the guidelines to start the project. And just like our teenage, in my teenage age, I just work out my Senga, my blog, by modify some CSS, something like that. And I think it's a good starting point to modify the app in the style way to get started and taste what's happening and what code change will get the app refreshed and fit your expected view. 下一種其他問題。後面嗰位先啦。Few months, I think. I just spend time on weekend because it's pandemic, the period of pandemic. So I guess maybe like for the prototype is currently I can focus on my work, on other interests, and maybe 1 hour per week.啱啱我諗呢個問題要答 documentation 要點寫得精細咧，都一定可以再好啲嘅。咁但係我會調翻轉諗就係其實會唔會喺寫曲方面已經寫得好咗？同埋我諗呢個 problem 即係巴士呢個 problem 比較日常啲。其實每個人要入場咧個理解對成個道理解都會好，所以喺 documentation 方面冇花特別多嘅時間。最關鍵嘅時間就係擺喺點樣launch 起個 project 啫。咁就冇講話裡面啲 API 其實係乜，因為其實 API 嘅量咧好少嘅啫，即係都係攞架巴士嘅即係幾點到啦，咁得呢個最關鍵嘅 API，其餘就係攞個 database 啦，可能係得3-4條 API，喺個 function call 一定知係咩嚟，同埋我哋已經有 example 寫咗俾佢㗎。 咁至於裡面成個 front end app 咁點樣去咧？咁我都係覺得應該係一路改一路試咧就會比較好啲。咁但係的確係如果要做好啲，一定可以再好啲啦。咁但係我自己檢討就會係見到有20個到嘅 contributor，咁其實應該都係 fruitful 地，應該我相信個 project 本身應該係有 readable 先可以參與到佢改嘅，所以就
而家你係仲係呢個 project 嘅 main 話嚟㗎？
係啊，都仲係每個禮拜仲花少少時間。應該時間到啦，我哋睇下問到個問題。好好啊，多謝你嘅問題。咁呢個問題咧喺個 Telegram group 啊，或者係同人都問過嘅。咁就作為個 app 嘅 founder 咧，其實我係希望呢個 app 死咗佢就算㗎啦。咁個原因係我唔使花時間再聆聽，呢個係好事啦。咁同埋如果有嘢可以取代到佢咧，即係俾佢好嘅，咁俾佢好嘅嘢取代到佢，咁我應該係用同埋拍手掌係支持佢嘅。咁所以啱啱提到就係5年後、10年後係點嘅話，我就覺得即係我比較佛系啲啦，都係覺得如果佢 ongoing。keep 住有 update 到就 update 啦。咁但係如果有啲好革命性嘅嘢下取咗，咁至於加其他嗰啲 function，即係飲食啊嗰啲咧，就因為個 project 就唔係 profit 嘅，即係都冇打算變成 profit 啦。咁所以就冇興趣去加任何呢啲potential 可能令到個 direction 唔知走咗去邊嘅位啦。咁就 focus 翻喺佢原本嘅定位就係咁。咁就希望就快啲有啲年輕人。係就寫個好啲嘅 app 用得爽啲嘅，咁就直接取代咗佢啊，就更加開心啦。咁個社會一定會更加進步啦。係就係咁。好，唔該晒咁多啊你。
Testing. Thank you for sharing. If you would like to discuss with our speaker about the topic, you proceed to the social area outside. It's 12:30, and he will be talking about test through 12:30. Good afternoon, everybody. Coming up next, we have Charles Chen to share about learn supply chains attack through XEZ Utils Blackdoor. Let's give him a warm welcome.
Thank you so much. Thank you so much for joining this section. And today I will going to talk about learning cyber chain attacks. Just have jobs recently or start people. Okay, so hope you can learn and just introduce myself. I'm just a fresh graduate in Hong Kong UST and majoring in computer science. I am a member of the Black Blauhinier, which is a CTF team, and also a core member of HKOSCon cyber team. And I'm interested in cybersecurity fields, especially and walk you through what is cyber attacks, and I will just tell you the whole stories, how is found to be compromised, and virus. And I will also talk you through some popular patching attacks and what we can learn from all these stories. And before we start, just of efforts, doing bad things will got you into jail. So don't do bad things, or you will be in the jail. So just do those bad things. And let me just explain about what is cyber chain attacks. Before knowing that, this is a traditional cyber chain. Basically, you will got a supplier, supply some I don't know, some resources to the manufacturer, and then the manufacturer will produce the products, and the distributor will just distribute those products to the retailer, and the retailer will give those products to the customers. For a software, similar things, and the engineers will just change those products. It will and put it into some applications, and then handle it in systems. And how can we do cyber chain attacks? Basically, if we can change software, modify those folks, making it attackable. What cyber chain attack means, and we have different forms to do this kind of things. We have like software updates, changing those software libraries, changing those firmware. Term called whole attack. If you want to learn more, just search this link. And the story we want to talk today is basically this one, a software update containment. And how this exact Unity found to be compromised. So first, just explain about what these libraries do. This is used to compress and decompress a file format called XZ and also LZMA. What XZ is, comparing to others alternatives, it have a much higher compression ratio. So this libraries is really popular because number of Linux distributions like Ubuntu, Debian, and also Mac OS use XZ to compressing their software packages. So this one is my MacBook, and with this string, you can just check your version number. And what this special is, some of those Linux distributions, they're open SSH to support systemd And this you have use and just a SSH in 5.6.0 and 5.6. First of the and achieves by bypassing the authentication. So so how this who my I suddenly found that section find a lot of that there
設定咗下場喎，title B 嗰個。咁轉咗呢個 A B 咁樣換咯。撳入去嗰個 folder 仔。開始啦。
Good afternoon. Coming up next, we have Toby Cho to share Sorasi, a reverse proxy server for networking beginners. Let's give him a big hand.
Right. Thank you for the introductions. I'm Toby Choi. Today I'm going to talk about Sorasi. So this project is contributed by quite a number of contributors, and I'm the primary author here. I'm currently still a master student and a director of a startup company. So 2 years ago, I'm like a complete networking noob, right? I have zero knowledge about self-hosting or reverse proxy. Like I don't even know what is a domain. What is how can I host on a website with like IP address without the port card in the URL? And I don't even know how to set up HTTPS, like green lock in your browser. So anyone have the same issue like me before, like 2 years ago? No idea what the reverse proxy? Anyone? All right, one. Nobody? Okay, seems to be all expert here, right? So I'm going to talk about basics of reverse proxy and why they're commonly used in home lab setups. So what is a home lab? A home lab is basically a server you put at home for testing lots of IT stuff. And it can be as simple as an old PC sitting in your closet or a full-size rack, a professional rack in your house basement. But most home labs I know have something in between, something like a small rack with a few NAS and networking equipment at home. So a home lab, a small-scale, non-production network environment for testing IT skills and learning a lot of new technologies. But recently, I'm seeing more and more people hosting their own servers, maybe an OPC or an old Raspberry Pi, for hosting services to replace subscription services, like maybe Nextcloud or RSOS, or Google Drive or Jellybean for replacing Netflix, etc. So in such scenario, a reverse proxy server is really important because it helps proxy the request from your downstream devices like your laptop with browsers to upstream servers like origin servers, like web servers, for example. And if you don't have a reverse proxy, like you own a domain name, right? And you want to create a new subdomain, you need a dedicated IP address for it, which is not quite feasible, considering that we're running out of IPv4 address right now. So that's where the reverse proxy is important in such setup, because you can point multiple domains or subdomains into a public IP address that has your reverse proxy server running, and let the reverse proxy to forward the request to maybe a dedicated IP address or your local server in your local area network. And this is really important as the gateway of your home lab server because most of the open source projects rarely works together with shared web servers. Some rare exceptions like CGI or fast CGI with PHP server, but there's really exceptions right there. And a reverse proxy server is generally needed for your home lab setup if you're trying to run a lot of services into it. Like you can have your Jellybean, your domain.com pointing to your Jellybean instance, or your Portainer, your domain.com pointing to your Portainer instance on different port. Like you're using Docker or virtual machines with IP address, etc. So for such an important piece of software, there are obviously some already open source solution out there. One of them is Apache Nginx, which is the most traditional one that maybe an IT person would pick. But if you want to like something like a WebSocket proxy or geo IP access control, you need plugins and you need to write a lot of text-based configuration files, so not technically beginner friendly to start with. And for a more modern solution, there's a KD servers within Golang, which is lightweight but still based on text-based configurations. The traffic proxy is a good alternative. It is commercial. It has a commercial and open source version, but their dashboard is quite limiting and can only perform some simple configurations. So if you ask the question on Reddit, like what is the best reverse proxy server you recommend, most Redditor will tell you to use the Nginx proxy managers because it was the only one out there with a decent UI. But the downside of NPM or the Nginx proxy managers is that it requires Docker to install, and if you're running on Windows, then you will see a lot of networking and NIC kind of issues right there. And from 2021, this project is rarely maintained, so most of the issues recently are complaining the application is broken. They have a V3 coming soon. They claim that it's written in Golang, but
It also didn't update much since 2021, so I doubt it will come up anytime soon. So that's why I developed my own reverse proxy from scratch. And here comes the Soraxi project. So what is Soraxi? Soraxi is an open source reverse proxy server solution with some handy networking tools. It is licensed in AGPL, run on Linux and Windows. Everything is a single binary file, so you don't need an installer or any kind of things. You don't even need Docker to run it. It just runs natively on your Windows or Linux server. It has a beginner-friendly design with straightforward buttons and UI stuff, with lots of automatic configuration generation built into the Soraxi project. Many people coming from the Nginx proxy manager complain of this project being too simple, or they're blown away by how the things are automated in the design of Soraxi project. To sum up, the core about the Soraxi is the reverse proxy based on HTTP2 because we're more interested in HTTP3 now. It supports virtual directory, WebSocket proxy, basic auth, alias, hostname, custom handler, basically anything you will find in the other reverse proxy project you can find in Soraxi. With the help of our contributors, we also added a lot of TLS and SSL support, including ACME, SNI, and SAN certificates, DNS challenge for less encrypted, etc. Other features include access control manager, so you can blacklist, whitelist, or rarely limit the country or IP address. If you're using zero tier, it also got built-in web UI for that, so you can have unlimited members in your game network. It also supports stream proxy, so if you are trying to proxy for your game server like Minecraft, then you can do it here as well. It also got a lot of utilities like integrated uptime monitors, web SSH terminal, and a lot of things. One of the key features of Soraxi is that it has a wonderful or beautiful UX and UI element, including some of the most modern UI you can find in open source projects. Some of the interface also resemble other kind of open source projects as well. For example, you can find the default site settings and the HTTP proxy list kind of resemble Nginx proxy manager of some kind. And also, if you are an AWS developer, you might be using Lightstyle before. You can use Soraxi as a kind of a proxy for your SSH terminal, so you can access your cluster or your server in an enclosed environment with this web SSH tool, and uptime monitor, just like Uptime Kuma, where you can know if your server is down and if they are working normally. There are also some statistical analysis, which I will talk about it in later sections, but in general, you can see real-time data of your site in table and chart like this. So I guess most of you have never heard of Soraxi before, because this is a really young project. It was a subservice module in the RSOS project. RSOS is another project of mine, which is a full-fledged web desktop OS. I added in just for fun. And later on, in 2023, I'm restructuring my distributed home lab. So I split this project off as a dedicated independent project called Soraxi. And after so many enhancement requests and updates, now we got the Soraxi v3, which is much more modern and efficient in reverse proxying. The problem is that you don't see a new reverse proxy pop up on GitHub every day. It's because it is really hard to test if a reverse proxy is compatible with other open source projects. Like maybe WordPress, for example, they require central headers, cause rewrite rule, and maybe sometimes other projects require web software update that is a little bit complex to configure. So instead of testing all open source projects and make sure it works with our proxy, we decided to test it on production instead. And where can we find free test users? Well, post it on Reddit. That's why we post our post on Reddit to share that we made a cool new project called Soraxi, and the project started kind of skyrocket after we posted on Reddit. And this is a screenshot from our GitHub page. It has 17K public pool yesterday, and from what we see on Reddit, people are using it as an Nginx proxy management replacement, which we didn't design it to be that way, but as more and more people from Nginx community coming into this project, they are asking a lot of feature requests that make Soraxi more and more looks like Nginx proxy manager. And from the latest UI, you kind of see the Soraxi UI resemble the Nginx proxy manager in some way. And just to be clarified here, I don't intentionally copy the design or anything, right? You just, enhancement requests come in and then we just do it. After the third one of this project release, we got a lot of people Dockerizing this app, which is a good thing. But the problem is that they are Dockerizing in a lot of different ways, I would say. And when people having issue with this Dockerized image, they come to our main repo and complain we don't make the app works. That is why in the third month of open source project, I invited one of the Docker maintainer into our project, and now we have an official Docker image. So Swarovski in general speaking, in recent months especially, is getting more and more production ready. As this is a technical conference, I will talk about a little bit on how Swarovski is built differently from other reverse proxy solutions. So first of all, many people confuse Swarovski as like a UI for Nginx or KDE, but instead, this is a project completely built from scratch using Golang. The good thing about working in Golang is that it's about Windows and Linux natively within the CPU architecture, so if you have an old router, old PC lying around, you just flash it into it. And it is self-contained, so it doesn't require JIT or runtime. And by the magic of Go embed, we can even embed all the web resources into the binary itself. So if you have Windows, double-click an exe file and your reverse proxy is deployed. It's that kind of simple. The disadvantages of this design is large binary size and no drop-in plugin. So if you want to add a plugin, you need to recompile the program, which we're trying to figure it out later. But if anyone got an idea for that, please let me know. This is the overall general structure of Swarovski. I try to simplify a lot of things here, but you can see the downstream here, which is the user device, and your upstream is the server right here. And first of all, the request will go through the TOS router, where a lot of things is done here to, for example, like get you the correct certificate to serve your request. And it passes through something called the dynamic proxy router. Why it's called dynamic, I will explain it later. Afterward, we'll go to this special router handlers, which will check for like rate limits if you are coming from a country that has banned you, or you are an authorized user. And then if everything checks out, we'll go into the primary proxy router, where we call it DP core, dynamic proxy core, where the actual proxy logic is handled, including how to switch between HTTP upgrade to WebSocket, and then the request is forwarded to the backend servers. So let's come back to here. Why is it called dynamic proxy routers? The reason it's called dynamic proxy router is because we are one of the few projects that allow hot reload and partial reload of some routers modules. That means that if you change any configuration in Swarovski, you can do a hot reload with no downtime. There are also more high availability features coming soon, including load balancing, automatic failover switching, multi-node context-sync, heartbeat, etc. But the magic of how we do the hot reloading is the utilizing of pointers of the manager inside the router options right here. I try to simplify as much thinking here as well, but in simple words, what we actually do is that because reverse proxy is a really high current and low latency software, right? There are a lot of requests coming in every second, and in order to make it hot reloadable, we actually use pointer swap techniques to swap the configuration and separate the abstractions of the reverse proxy logic into two layers. So dynamic proxy gives you a configuration on how this request should be routed, and the DP core is where the actual proxy logic handles. And by swapping the configuration pointers, what we can achieve is that even there's concurrent requests coming in, they will be able to have a real-time hot reload configuration, allow changes in the reverse proxy in real time with no disconnection or unstable connections. And after the connection using the old configuration is closed, the GC will kick in and clean up the old configuration. So everything is seamless and with no downtime. Also, Swarovski is famous for its UI-driven design. If you work in the tech industry, you know more infrastructure delivers code. So for example, like Nginx, you have a configuration files. And in Swarovski, we try to develop it UX first in mind, and its web UI even support Out.D, so you can control your reverse proxy on your phone for no reasons. And this design, we are trying to minimize the operation cost for small business and home labs, so that they can easily set up their reverse proxy without wasting a day to figure out why the configuration is not correct. And just now, I mentioned about statistical analysis, right? The statistical analysis in Swarovski requires no cookies. What it does is that it analyzes data purely based on header sniffing and Cloudflare hints. So if you use Cloudflare will send some headers with their request with some hints. And we use those hints to visualize them and show you your visitor data in real time using charts and tables. And you can even see where your visitors are coming from and what they are interested in. Talk about where they from. Usually, if you think about your IP resolving, you will call to some kind of AWS API or something like that. But the geo IP resolver in Thoraxy is completely offline and standalone, which means we don't use any kind of API dependencies. So it's perfectly safe for commercial use or with offline off-grid scenarios. It works by magic of custom written tree tree, so it has like 800 and 900 megabytes of tree tree within the program itself. So you can do a time complexity of near 0.1 speed of resolving the IP address into the country code. But of course, I know that some people are trying to deploy this on a router, like 10 years old router. So in order to compatible with those devices, we also implemented a fallback mode where it takes much more time complexity to resolve the IP address, but using much less RAM. There are also other worth mentioning features of Thoraxy might interest you to try using it, including one of the most easiest custom header editor out there. You can even just toggle some security headers like HSTS or permission policy and check the header security header checking method to give you an A grade. This is one of the key features of security experts will love this one. And as it is all integrated into a single binary, including the ACMD and DNS challenge manager, so that with no ACMD.sh or circuitboard, this program works natively on Windows and Linux. So the Thoraxy also got automatic SNI and SAN certificate, so you can generate a wildcard, a domain certificate with wildcard inside, and allow them to automatically match your request coming in. In Nginx Manager, what you will do is you create a certificate and map it to a host name, right? In Thoraxy, that's automated. So many NPM users just don't get used to this design. Also, one of the features worth mentioning is called SSH. This program is powered by GoPPY, which is another cool Go open source project out there. You can check out the link right here. And we use selective compilation to include this binary within our binary. So you can use your website, your browsers, to SSH into another server that is within the management scope of Thoraxy. From what I experience right now, most of the users using Thoraxy are for Docker use case. For example, you have a lot of containers hosting on a Dockerized network with different ports, and Thoraxy can proxy those requests from outside of the Dockerized environment and use subdomain to point to a dedicated instance. For example, like if you have Nextcloud running, you can point nextcloud.yourdomain.com to that Nextcloud instance running in your Docker with a dedicated port. Although Thoraxy works outside of Docker, it also works inside of Docker. But for beginners, we don't recommend this because most people will get a little bit troublesome in setting up the network configuration and how to forward the headers and those things, and making a lot of issues regarding the access control policies. So, as I mentioned earlier, I restructured my home lab structures, and this is how my current home lab setup looks like. I have a few instances, a few in Hong Kong, a few on Cloud VPS, and a few in my Taiwan home. And this is how I link everything together on my domain. Currently, Thoraxy is not production ready, but if you really want to try it, you can try it. And I've already got a few small businesses and independent design studio trying out Thoraxy, and all they are giving me some good positive feedback and improvement ideas. I know most of you are professionals here, but if you've got the time, feel free to contribute to this project because we are trying. Currently, we have a lot of users, and the user count is still increasing. And a lot of them are also beginners like me 2 years ago, where I have a lot of issues in setting up networks or how network routing actually works, and also a lot of bug report that is not actually bugs, but just they have misconfigured or something. So if you have the time and you know about how reverse proxy works, feel free to contribute by replying to these issues. This is all I'm going to share about today. And if you are interested to try out Thoraxy on your home lab, or maybe you have a spare Raspberry Pi, you want to put a website on it, feel free to scan this QR code and go to the project homepage. And if you have any questions, you can feel free to ask me right now. Anyone have any questions? Want to know more about this project? Yeah?
Do you plan to add support for encrypted client hello as well?
You mean TLS?
The extension for ECH.
ECH?
Is to hide the SNI.
No, currently there's no plan. And in fact, we have a dedicated maintainers who is from the US to handle anything regarding the TLS and the ACME part. So maybe you can open an enhancement request and ask him instead. Yeah, I mostly handle the reverse proxy core part. All right. Oh, anyway, if there's no questions, then you can feel free to check out my repository and project homepage over here. And my another open source project is called RSOS, where you can remove the Sorasi part of the domain and you can check out my another open source project. So I hand back the time to the MC.
Let's give him a big hand again. Thank you, Toby Cho, for a wonderful sharing. If you would like to discuss with our speaker about this topic, you proceed to the social area outside. The next session will be Michaelis Papas at 3:45 p.m. and he will be talking about beyond software defenses, hardware assist CFI on ARM-based systems. Good afternoon, everybody. Before start, we have an announcement. At 4:30 p.m. in MWT2, there is a lightning talk. If you are interested in this talk, just feel free to join and listen to some participants. Coming up next, we have Michaelis Papas, and he will talking about beyond software defenses. Hardware assists CFI on ARM-based system. Just give him a big hand.
Thank you. Okay, so hi everyone. Thank you for joining this talk. My name is Michalis. I'm a staff engineer at Unicraft. Unicraft is an open source unikernel operating system that I regularly contribute to and also co-maintain with others. And Unicraft GmbH is a startup that uses Unicraft to provide cloud services. So my motivation for this talk is the work that I did to provide hardware-assisted CFI for Unicraft and ARM64. So this is the result of my work and the knowledge that I obtained by going through that. So what is control flow integrity, first of all? So most software attacks rely on subverting the execution path to malicious code, right? So by control flow integrity, we refer to a set of security techniques that actually try to limit or restrict the code execution flow to the intended execution path. So let's have a brief overview of CFI attacks and the mitigations and how they evolved over time. So during the 90s, buffer overflows were the big thing, right? So I think you all know how these things work. If you can override the buffer in the stack, then you can write your malicious code there, and then you can also override the return address to point to your malicious code, and then it's game over, right? And from that point on, a cat and mouse game starts, where people start introducing mitigations, and of course, researchers start demonstrating ways to bypass them. So the immediate response to buffer overflows was the non-executable stack, right? So mapping the stack as non-executable now prevents the attacker from executing their malicious code, so they can write it still on the stack, but they can no longer execute there. And of course, right after, people demonstrated ways to work around this. So the first code reuse attack was demonstrated by Solar Designer. It was a return to libc, so now instead of executing your own code, you return to execute the existing code in the standard library. Meanwhile, other defenses were introduced, like StackGuard and StackShield. These are stack canaries and shadow stack, or ASLR, where the virtual address space is randomized and then the attacker doesn't know in which address to return. So, of course, in every single time, people demonstrated ways to bypass these protections. So, at this point, the CPU vendors started introducing dedicated countermeasure for software attacks, and most famously the non-execute bit. And with that, what actually happens is that you can have memory either writable or executable, but never both, right? And this is the end of, let's say, puts an end of the possibility for attackers to execute code that they have provided, they have written in memory, right? And at this moment, of course, the focus from the attacker's side goes into code reuse attacks, and this is when return-oriented programming and jump-oriented programming and all these techniques become popular. I will not go into much detail about how these work. What you need to know is that instead of writing your own malicious code into memory, what you do instead is that you find small chunks of this code into the existing program, right? And these are called gadgets. And then you somehow get the execution to execute these gadgets one by one. So little by little, you eventually get to execute your malicious code via existing code and not by code you have supplied into memory. The problem with return-oriented programming and jump-oriented programming and all these techniques is that it's very hard to defend against with software, right? So these have become very, very successful attacks. And of course, at this point, CPU vendors start looking into hardware-assisted mitigations. And this is what we're going to be looking at today. So we will focus at ARM, and specifically pointer authentication and PTI. But before we get there, we need to define our threat model. Pay attention to this because this is very important. Our assumptions here is that the attacker has obtained read primitives and write primitives, so they can read and write into arbitrary addresses in memory, and they are trying to obtain arbitrary execution. The other very important assumption is that, of course, a non-executable stack is in place, because if you don't have that, then you fall back into traditional buffer overflows, right? So let's start with pointer authentication. So pointer authentication is a mandatory extension in ARM v8.3 and ARM v8.6. So as the name implies, it relies on authenticating pointers. So of course, there is a cryptographic operation to sign the pointers first, and then another one to authenticate them. And how it works is that you start off with, of course, the pointer that you need to sign. The pointer has some upper bits that are unused or almost unused. We will see exactly in detail why that happens. And then you have, of course, a secret key, and then you have also an additional modifier value. You pass the address to the cipher algorithm, and then the output of the cipher algorithm is XORed with the upper bits, and that forms the signature. This is called the pointer authentication code. This now replaces the upper bits, and now you have the signed pointer, which consists the signature and the address. So let's look in more detail about the upper bits. So first of all, why do we have upper bits in the first place, right? So in 64-bit systems, pointers are not 64 bits wide. The pointer size is configurable. In Linux, the default is 48 bits, but you can configure the size of the virtual address to be between 30-something up to 50-something bits. Let's stick to 48 bits now because this is the default, but you can imagine that this can vary, right? So what can go into the signature you see here is what you see there as extend bits. I will not explain in detail what these are, but just keep in mind that the signature of the pointer can go into these yellow blocks, the extend bits. Sometimes, if you have other features implemented, like what you see there, MTE or PTI, again, I will not explain what these are, but you can keep in mind that other security countermeasures or other features can reserve some of these extended bits. And then this means that you have less bits for the signature, right? Yeah, that's it for now. So, how about the key? So, the ARM specifies that you have 5 different keys. You have 2 keys for signing instructions, instruction key A and instruction key B. You have 2 keys for signing data and 1 key for generic purposes. And it is down to the operating system or the compiler to decide how to use this. So you can imagine, I don't know, theoretically, that you have an operating system that uses key A for its own purposes, for the kernel, and then uses key B for the user space or whatnot, right? It is really implementation defined. The modifier, you might wonder what it is about, because normally you would only need, let's say, a pointer and the key, right, to sign. So the modifier is very important because it puts some context and avoids a certain type of attack where an attacker can substitute one signed pointer with the other. But if you use a modifier, then you limit a signed pointer to a given context. And The most common use is to use the stack pointer for that. So then you say, I assign the return address with the given key for this particular value of the stack pointer. So now the sign pointer is also limited to this particular context, right? So changing the value of the modifier, of course, will result in a different signature. Okay, so the cipher. So the reference cipher is called Karma, and it is designed by Qualcomm and ARM. So it's a block cipher like AES, which means that it operates on blocks of fixed size. It's called a lightweight tweakable block cipher. Lightweight because, as opposed to AES or similar block ciphers, it provides just acceptable security for a given purpose, right? It's a purpose-designed algorithm, and therefore the security has to be good enough for the purpose. Unlike generic block ciphers like AES, that they have to have like, I don't know, full security or as good security as possible. And tweakable means that you have this additional modifier parameter. In point authentication specifically, you have two variants, Karma 5 and Karma 3. Karma 5 has 5 encryption rounds. Karma 3 has only 3 rounds, which means that it sacrifices a bit of security for performance. All the implementations, all the reference designs from ARM that I've seen, they use Karma 5. You can also have an implementation-defined algorithm, and this is exactly what Apple does on the M series, right? They use their own algorithm, they don't use Karma. Okay, and of course the opposite operation, the authentication, you start with your authenticated pointer. You pass the address part again through the cipher with the same secret key and the same modifier. Just for reference, the modifier is not secret, right? And the result of that, you XOR it with the existing point authentication code. If everything goes well, then you end up with the upper bits that you had before, and then your pointer is authenticated. If something goes wrong, which means that if your, I don't know, pointer was modified or something like that, you will end up with an abort. Okay, so moving on to the implementation, ARM has added new instructions into the instruction set. There are two big, let's say, classes of instructions, the basic instructions and the combined instructions. The basic instructions provide instructions for authenticating, for signing a pointer, authenticating, or stripping the signature from a pointer. And it's 32 of them because although there are essentially 3 operations, you have all the variants, right? So you say, I have one instruction to authenticate a pointer with instruction key A and modifier, I don't know, the stack pointer. You have another instruction to do the same thing, but instruction key B, right? And for other modifiers and so on and so forth. But in practice, you have these 3 operations. These are implemented in the processor's hint space, which means that for, if you execute these instructions into an older processor, the processor will execute this as an op, so nothing will happen, right? Your code will keep executing, of course it will not be protected, but it will be backwards compatible. The combined set essentially does the same things, but with additional operations. It's, let's say, a convenience, so you can have authenticated return. Rather than doing first the authenticate and then the return, you can do both in one instruction. You can do other things like authenticated branching, right? If you need to jump from one part of the code to the other, you can do it in an authenticated way. Authenticated loads, and so on. These, unlike the basic set, are fused instructions, which means that they are either supported by the processor or you get an abort. So if you try to execute code with these instructions into an older chip, it will just not work, right? You get an abort there. So this is how it looks like. You can see on the left side, you can see a function protected with point authentication with the basic set, and on the right, you can see the combined set. So how this starts, first of all, this is to protect the return address, right? And the first thing that happens is that you sign the return address with instruction key A. You see this IA part in the instruction, and with modifier, the stack pointer. Then, of course, the function executes as normal, and before you exit the function, you authenticate the return address, and then you do the return. The only difference with the combined set on the right is that the authentication and the return happen in one combined instruction. Of course, the other difference is that the basic set is, as I said, backwards compatible with older chips, right? The right one is not. So that's it, more or less, with pointer authentication. Of course, there's much more there, but at least these are the basics. So let's look at BTI. Well, I'll drink some tea first. Okay, BTI is again a control flow integrity measure. It's a little bit different than point authentication. BTI is also a mandatory feature, which means that from some point on, it will be available on every processor. And it mitigates against indirect jumps. What is an indirect jump? Let's start with what is a direct jump. So when you need to jump into different parts of the code, with direct jumps, the compiler knows where you want to jump, and then the instruction that does a jump is relative to the current instruction plus, minus, and offset. These are not vulnerable, right? Because the instruction literally looks like jump plus, I don't know, that many bytes, right? Indirect jumps, however, are a bit different because the jump happens, is based on the value of a register. And this means that this is vulnerable to attacks because if the attacker can manipulate the register, then they break the control flow path to jump to wherever they like, right? And this makes it capable for these jump-oriented programming attacks and so on. So, how BTI looks like. When we compile code with BTI support, the compiler tries to find what are the possible places that indirect branches will jump to. So let's say the branch target, and we'll add this BTI instruction there. So if any code jumps into any other instruction that is not BTI, an abort will be generated. And that ensures that all jumps happen at legitimate instructions and not to attacker-controlled instructions, right? Or at least that's the idea behind BTI. So how is this implemented? First of all, yeah, as you saw, there is this BTI instruction that is new in the instruction set, and it also has a type. The type encodes the type of the branch, and this is similar to the modifier, right? It tries to restrict further the origin of the jump, right? So you have, I don't know, type for calls or type for jumps, or some types can be, some jump targets can be legitimate for both, and so on, right? So you still try to restrict a little bit the origin of the jump. And as far as backwards compatibility is concerned, BTI instructions are also implemented in the hint space, which means that again, code compiled with BTI running on older chips will still work, but of course without the protections. In addition to the BTI instruction, there is also a page table attribute called guarded page. So when you create your page tables, if you map a page and mark it as guarded page, then it will be protected with BTI. Any pages that don't have this guarded page attribute enabled, then they are not protected by BTI, and then BTI instructions there will be ignored. And this allows again for backward compatibility and so on and so forth. Finally, we have some bits in the process state. So The process state is a register that holds bits related to the execution state. So what you know for sure is these bits that are the condition flags that say, I don't know, the carry flag, the zero flag, the overflow flag, that show what happened after an arithmetic operation in the processor, right? BTI introduces additional bits for branch type into the processor state, and these encode the type of a branch. So bit type is updated on every instruction. So if one instruction is not a branch, then the bit type bits will be 0. If it is a indirect call, it will have a value. If it is an indirect jump, it will have a different value, and so on. And this means that actually when you do a jump, it's not only enough to jump to a BTI instruction, but also the BTI instructions have to match the value of the bit type, right? So as I said, this is similar to the modifier. It restricts your jump targets to specific origins. Okay, so now that we have all the background, let's see what is the current state of support in the ecosystem. So first of all, both GCC and CLang support both point authentication and BTI. They use the same flag called the branch protection to control these features. You can choose if you want any of them, whether you want point authentication or BTI, or both, and so on. However, the compiler support for both GCC and CLang is pretty basic. So, especially point authentication only protects the return address. So you don't have, as you noticed earlier, there are also instructions for protecting, let's say, do authenticated load, right? Or authenticated jumps. GCC and CLang do not support this. So, for example, the C++ vtables are not protected, right? And so on. The idea, I think, is that for these things you rely on BTI. However, Apple uses their own fork of CLang, right? And Apple has a much more complete support for point authentication. There is an interesting paper that goes into a lot of detail for Apple's implementation, and I think it's a very good read for that. Okay, operating system support. We will focus, of course, on Linux and Android. So first of all, there are options to enable or disable these features, both for the kernel and for user space, or for either. For the user space, you have keys generated, separate keys for every process, which means that when the kernel does the context switch from one process to the other, it has also to switch the keys because they are stored in registers. And within a process, the same keys are shared between threads. When a process does a fork, the keys persist, and they are only updated when the process does execv to switch to a different process. On the kernel side, you only have the instruction key A, and because also user-based processes, of course, use instruction key A among all the others, the kernel has to update the key upon kernel entry and kernel exit to its own key. Once again, Apple has a much more complete implementation, so it will be interesting to have a look there. Okay, hardware support. You will see that both features are becoming now ubiquitous in all type of major ARM processors. So you can see system-on-chip design for the cloud, like the Graviton, or for desktop and all the major mobile vendors. Eventually, they support more or less both. And time to go for evaluation. I think this is the most interesting part. So, how secure are they? Of course, the probability for a successful brute force depends on the number of bits of the signature, right? And this table shows the probability for different virtual address size, with the various other features that reserve some of these extension bits enabled or disabled, right? So you can see for 27 bits, the probability for a successful brute force is very, very low. The worst case, of course, is 52 bits with 3 signature bits. This is pretty uncommon, right? The 48 bits is much more common. You have there probability 1 over 128. However, what is important here is that the first time when you do a brute force, you fail, then you get either application crash or kernel crash, right? Because you get the abort, which means that you cannot do like brute force, right? You fail once, you're done. Then either the process is restarted or the kernel is restarted, then you get new keys generated, you start from 0. So brute force is not an option there. Also notice that pointer authentication is not vulnerable to information disclosure like ASLR, right? The keys are stored into registers. They are not stored into memory. Remember the threat model, right? The threat model said that the attacker has arbitrary read, arbitrary write, and is trying to get arbitrary execute. However, the keys are in registers, and to read the registers, you do it via special instructions, which means that you need execute path, which you don't have, right? So information disclosure is not the case here. For BTI, you have, let's say you have an object with a number of BTI instructions, and you want to have a chain, to find a chain of n gadgets, right? And if we assume that the number of indirect jumps in a given object is around 1%, then the probability to find a certain number of gadgets approaches 0 as the number of gadgets grows, right? So again, at least the theory is very much in favor of the defenders. Okay, how effective is this? So ARM has various white papers where they claim things like, I don't know, 50, 60% improvement, 70% improvement, but they don't provide enough information to reproduce their numbers. And I was quite annoyed by that, so I thought I should do this myself, because you should not trust, especially the vendor that advertises something. So I took Unicraft because this is the operating system I'm familiar with. I did this work for Unicraft, right? So I thought that I should benchmark with Unicraft also because it's pretty small and so on, right? So I took Unicraft and I compiled it for Nginx. And then I used Rob Gadget, which is the de facto tool for finding these small chunks of code called gadgets to see actually what is the effect of ARM's protections, right? So with no protections, I found around 40,000 unique gadgets. Then with point authentication it's the same. I excluded all the authenticated returns, because then these gadgets are no longer valid because they're protected. And I ended up with around 3,000 unique gadgets. So this is a huge improvement, right? The number of gadgets was reduced by more than 90% with point authentication. And of course, this is only for return-oriented programming because, as I said, GCC and CLang for Linux only protect against ROP, right? Now, you will say, okay, why 92% and not 100%, right? Where's the other 8%? And I started decompiling code and looking, and then I found a common pattern in both GCC and CLang that you'll see here that the red part is not protected, right? The protected code starts after that. And I'm not a compiler engineer, and I have no idea why, but given that this pattern is common in both GCC and CLang, it might have to do with how the compiler, I don't know, processes with different iterations the code, or generates it with different iterations. These parts of unprotected code, though, are very small chunks that do something like, very simple, like check a function parameter on entry, and then if it's, I don't know, invalid, just return, you know, throw an error, something like that. So this is an open question for me. So if anyone has any idea, I would be very interested to know why. I'm even tempted to open a back report in GCC and C-Lang and see what actually the compiler engineers say about that, because it's very, very interesting. Okay, so I did the same for BTI. Defining job gadgets, it's a little bit more tricky than ROP gadgets, but it's not also that hard. So when we say depth, we mean a certain number of instructions. So the depth of a gadget is, let's say you want your gadget to consist of, I don't know, 3 instructions or 5 instructions, right? Essentially, a job gadget is depth number of instructions until an indirect jump. So I patched ROP gadget to remove return because I assume that return is already protected by pointer authentication. And I ended up with 8,000 unique gadgets. Yeah, okay, this is my patch for removing the return, just for full disclosure of my methodology. And then I enable BTI, and then I want now to find also how many gadgets are left with BTI enabled. So how do I define now a job gadget with BTI enabled? It is again a certain number of instructions that end up with an indirect branch, but they also have to start with a BTI instruction, because I cannot jump to anything else other than BTI, right? So, of course, ROP gadget again did not support this, it doesn't know anything about BTI, so I had to come up with some post-filtering ideas. So you can see this command line there, that I had to come up to filter out what I wanted to find. But either way, I ended up with 48 unique gadgets. So from, where was that? 8,000, right? You end up in 48. And in practice, this is even smaller, because I don't take even into account the branch type here, right? So it's even less. So this is more than 99% improvement, which is, again, it's great, right? Okay, so performance. What is the overhead of these things? So for pointer authentication, you have one instruction at the end of the function and one at the return, assuming the combined set. So you have +2 instructions per function. If we look at the optimization guide of Neoverse, which is one of the reference designs of ARM for cloud, you can see that the authenticate takes 5 cycles, and the authenticated return, the sign takes 5 cycles, and the authenticated return takes another 5 cycles. So in practice, we have +10 cycles per function. 10 cycles are, I don't know, 5 multiplications, right? It's okay. It's not so big, right? It's not negligible, but it's still not so big. For BTI, things are much simpler, right? You have only +1 instruction per indirect branch. And although in the optimization guide, I looked at all of the ones that I could find, they don't document it. I think it's safe to assume that it's only one cycle there, because it just does one check against the processor state branch type. So this is one cycle per indirect branch, and if we stick to the assumption that indirect branches are 1% of the total instructions, then again, this is nothing. Of course, I wanted to still take some measurements in practice, so I compiled Unicraft for the NBench byte benchmark, which is a very common benchmark that people use in the papers and so on. And also I did the same for NGINX using the WRK stressing tool to see, measure the request per second and the transfer per second and so on. And I executed this with QEMU on an Apple M2 using HVF acceleration. HVF acceleration means it's the same thing as KVM, right? Your code executes on the host CPU. There is no emulation there. So you're running really on the M2 processor, even though you're running on top of QEMU. And what I saw was nothing, right? The performance looked exactly the same, which means that at least when you run on top of a VMN, then the overhead is non-perceivable. Of course, if you run directly bare metal, you should be able to see that even these few instructions overhead, but not on the VVM. So it's masked most probably by the noise of OS entry, OS exit, and all these things. which is, of course, fantastic. Finally, the last metric was the code size. How much do these extra instructions grow our image and, of course, our memory footprint? And ARM claimed some very small numbers. Long story short, I did something similar, and again, ARM's numbers seem credible, right? So you have something like, I don't know, even less than 2% growth in the image size, which again is very good. So, in practice, are now CFI attacks over? And the answer, as you can guess, is no, right? So, actually there is a lot of interesting reads on this. Pacman is a side channel attack, which means that they managed to break point authentication in PTI via side channels. If I remember correctly, ARM already introduced an extension that addresses this. All the rest are workarounds. Or, I think one of the first ones was a bug implementation in the XNU kernel of Apple, right? They did something buggy and people could then reuse, I think, SignPoint or something like that. So all the rest is workarounds. So does it mean that these protections are broken? By no means, right? It's very hard to attack point authentication in PTI. Normally people work around them, and then you have also new protections coming in, like MTE in particular, that will make exploitation even harder. Okay, so in conclusion, so point authentication in PTI are performant and they're effective. They're great value for money because the implementation effort for the improvement ratio is very good, right? They're pragmatic. You don't need to rewrite code, like how people, I don't know, propose, I don't know, rewrite everything in Rust and etc. Right? You only need small implementation changes in the kernel to enable the feature, and overall, it's a very big step forward compared to software mitigations. Eventually, also, they will be present in every ARM-based system on chip. And even though they have been proven actually not possible to, well, not impossible to bypass, they're still, let's say, a big improvement because they make exploitation significantly harder. As I said, there are more mitigations on the way, especially MTE, which I think addresses the problem of memory safety at its core because it detects memory violations when they happen. And of course, there is also Cherry that is based on fat pointers with capabilities. That is something very promising for the future. Okay, so I'm done. Thank you very much. And if there are any questions, I'll be more than happy to answer.
What about the compilation time?
Cool. So the question is, what about the compile time? The answer is, I don't know. I have not measured it because normally compile time is cheap. You don't care about compile time. What you care about is runtime, right? For compile time, you have even like entire servers to do the build for you, but I don't expect to see any significant also increase, like penalty in the compile time. Yes?
For PO, where did the process key store at? Is it stored in the user space or kernel space, and is it stored in the register or somewhere in the memory space?
Okay, so the question is, when we do the process switch, where are the process keys stored, right? And these are stored in memory in the kernel space.
Kernel space.
Yes, of course, because the kernel will save the context of every process, right? Anyway. So now you have additionally the contents of the key register to store on the kernel. And then when you do the context switch, the same way how you restore the context of the process, you also have to additionally restore the keys. Okay, I think I have no more questions, so thank you very much.
That's the end of all sessions in MWT1, and thank you Michaelis Papas for for a wonderful sharing. To those who are interested in lightning talk, just feel free go to MWT2 and it will start at 4:30. And remember to join the lucky draw about JetBrains license after the lightning talk.